Hello, Dr. Deming. How are you?
Hello, good morning.
Good morning to you as well. Dr. Deming, we are right on time. So should we start the session? Because mostly almost 200 participants are there on the live channel. And
I
here
see.
only selected participants and the moderators are only here in the Zoom meeting. So
Oh, okay.
we will be narrating the questions they posted on the YouTube channel and our Google questions form.
I
They will be
see.
narrating that, and
I see.
then we will be asking the question from you.
I see. Okay. So most of them are actually in the YouTube or some other
Yes,
places.
200 participants are almost there.
Oh, wow. Okay, that's fantastic. Great.
So should I formally start the session?
Sure, whenever you're ready.
Okay, thank you. Hello, everyone. Good morning from Pakistan, and a very warm welcome to all the participants and the speakers in the last and the sixth day of IBRO APRC Associate School of Neuroscience. This was a very great experience for being with you guys whole week. Today we have some very great talks with us, and then we will be following up with this e-poster session from the participants who get selected. Today we have with us Dr. Deming Chow. He is MD. He is representing Young Scientist Network, Academy of Science, University Putra, Malaysia. Dr. Deming is a senior lecturer at Department of Biomedical Sciences of the Faculty of Medical and Health Sciences, University of Putra, Malaysia. He has been teaching genetics and ethical issues in genetics and stem cells for more than 4 years. And Dr. Chow chairs the Science Integrity Group of the Young Scientist Network, Academy of Sciences, Malaysia. And he is one of the founders of YSN ASM Responsible Conduct of Research, that is RCR program. One of the key initiatives of his RCR program is to promote research integrity, which is very vital, and research ethics in Malaysia. So he is one of the co-editors and co-authors of Malaysian Education Module on Responsible Conduct of Research, which is a key RCR reference material in Malaysia. We are very much privileged that he is here, not only talking about this very core aspect of research and neuroscience, but also he's representing IBRO and delivering this entitled talk, which was mandatory for all the participants by IBRO to conduct this basic neuroethics session. Thank you so much, Dr. Deming, for joining us, and over to you.
All right, thank you very much, Dr. Sadaf. Right, would you just do a sound check? Can you hear me clearly?
Yes, perfect.
Okay, that's fantastic. First of all, thank you so much for giving me this opportunity to give this topic, to talk about this topic on ethics as well as on ethics in neuroscience research. I have been teaching about ethics for the past 4 years, and neuroscience, although I had a bit of experience in neuroscience research, but the concept of ethics in neuroscience, it's kind of relatively new to me as well. So it's really a privilege to come and give this talk to all of you here. Even though I can't see other people in here, but it is really a pleasure to know that there are at least 200 of you listening in at this moment. For today's session, I have 1 hour, and I would like to make this as interactive as possible for all of you, because I feel that I want to make it interesting for you. I want to make it so that you as participants who are listening in, you will be able to also engage with me during today's session. So I will be giving you some website link for you to answer a few questions, to write a few thoughts, to choose the multiple choice questions. So I would like all of you to have your computer or your laptop ready, and I will give you the website in a moment that you can log in and share your thoughts with us. So I'm going to share my screen right now. I hope all of you are able to see my screen. Yeah. So the topic given to me today, it's about ethics and neuroscience research. And I'm from University Putra, Malaysia. I think many of you have met Dr. Chow Paiksi. So she and I are colleagues here at UPM. I am going to start with the learning objectives. So by the end of today's class, you'll be able to, number one, describe the definition of ethics. So what exactly ethics is about. Number two, then we move in a bit deeper to talk about medical ethics. I think many of you here listening in are researchers. Therefore, we want to go one more level down to talk about medical ethics and research ethics. And finally, we'll spend a bit of time, since this is an IBRO event, that I need to talk about neuroscience. So hopefully I will bring some of the ethical dimensions into discussing neuroscience research. So these are the 4 learning objectives that we have today. I am going to start with a case study with all of you. And the case study is based on a story, a fictional story that I created. And in this story, imagine all of us here, including myself, we are all taxi drivers. So just imagine we are all taxi drivers today. We're driving our taxi around in Pakistan or in Kuala Lumpur here in Malaysia. And imagine it is at night, Saturday night at 11 p.m. So it's 11 p.m. on a Saturday night. I don't know how the streets are like in Pakistan, but in Malaysia, Saturday night, 11 p.m. is pretty quiet. And you got a phone call. The phone call came from a woman who is about to give birth to her baby, a pregnant woman about to deliver a baby. And this woman needs to go to the hospital immediately. And you, as the taxi drivers, was sent to pick up this pregnant woman. So this is a story. As you are driving towards the hospital, and you are about 2 kilometers away from the hospital, pretty near, 2 kilometers away, and you hit a red light. The traffic light shows red and you hit the red light. So my question for you, ladies and gentlemen, is this. Will you wait at the traffic light? Will you, with the pregnant woman in your car, wait at the traffic light? Now, what I would like you to do now is to use a phone or your computer or your tablet. Go to this website, www.menti.com. And once you are in menti.com, it will take you to a poll, right? A polling. And I would like you to type in the code. There will be a poll, and you will be able to click the answer yes or no. I hope this will work. I'm not quite sure. I'm not getting feedback, so I hope it will work. Maybe Dr. Sadaf can help me check whether it is working. So go to Mentimeter and then type yes or no. Would you wait at the traffic light? Are you all able to get in?
Yes, it is working.
Fantastic. So take a few moments to type your answers. Okay, I'm seeing some polling numbers coming. I will show you in a bit how 200 of you think about this answer. So again, the scenario is you have a pregnant woman in your car, needs to go to the hospital, and you are 2 kilometers away and there's a red light. Would you wait at the red light, or would you drive and run the red light? So I see a couple more responses has come in. Any more responses from the participants? Okay. So far, it's been kind of like slowing down. I'm not getting as much, but it is okay. I'll show you the result based on 7 of you who has responded to my poll. And the result looks like this. Let me see if I can put out my screen over for you to see. I will need to just give me a second. Trying to solve this technology issue here. Okay, it's not really working. Just bear with me 1 second. Hang on, just stop sharing screen. And let me just share screen on this side. Here we go. Okay, so the answer is, would you wait? And let me see the result here based on 7 people. I was hoping that we can have hundreds of you reply, but I see some chats. 4 of you say that you will not drive. You will not drive because it is red light, and 3 of you say that you would stop at the red light and you won't run the red light. And I see, looking at chat, I see a few people say you will drive, that you won't wait. Okay, so that is good. So let me just go back to this question then. Why would you wait? For those of you who choose wait, let's think about this question. And for those of you who say that you will not wait, why would you not wait? Right? So this is the question that I want you to think about. What is the reason that you would wait? And what is the reason that you won't wait? Therefore, here is the conundrum that we all face as researchers. And the conundrum is this. I'll go back to my presenter. In everything that we do in our life, there's always an issue of moral, laws, and ethics. As simple as driving to a hospital with a pregnant woman in our car, we are also facing this sort of decisions that we have to make. What is moral? Moral comes from our inner convictions and our conscience. It could be driven by our culture. It could be driven by the way we were brought up. It could be driven by what we were taught by our parents, our community. It could be driven by our religion, our religious worldview. That's where moral comes in. Laws, on the other hand, are the enforceable. It's written in the code of your country that if you break the law, you will be punished. If you run a red light and if there is a police, then you may be fined by running red light when you are not supposed to run a red light. Ethics, on the other hand, governs the idea of decision making. What should you do when you are faced with a decision that you have to make? Whether it is based on the law or based on your moral values, ethics is what you and I would base our decision on. How do we choose what to do given our circumstances? When you are a taxi driver sitting at a traffic light with a pregnant woman in your car about to give birth to a baby, what would you do? Do you apply the law? Do you apply moral in your decision making? Ethics, there are other ways to look at it. I think you can put it in a way that says, if you can do it, should you do it? Or the other way around, you cannot do it, but should you? This is what we call ethical dilemma. Why do I talk about it? Because in today's class, we will focus on the 3 areas of ethics: medical ethics, research ethics, and neuroethics. These 3 things might seem, they are all very similar. There are areas that they overlap with each other. But the point I want to make here is that today we will focus on ethics on decisions making. And hopefully, as I said, towards the end of today's lecture, I will bring out some ethical dimension in neuroethics. Now let's take a break, right, from thinking about these issues, and let's think about this question. What kind of ethical issues researchers should consider when conducting research? Put it another way, you as a researcher, when you are doing research, what kind of ethical issues you need to consider and you need to apply when you do your research? So I would like you to go back to Mentimeter. We used this Mentimeter a few minutes ago. And I would like you to key in a different code, 3303303. Okay, so let me just put this out. And you should be able to do this. So again, for those of you who are joining via YouTube or other platform, I would like you to participate in this activity. Go to menti.com, type in the code 3303303, and you should be able to see the question. What kind of ethical issues researchers should consider when conducting research? I'll give you about 30 seconds to 40 seconds to type in your answers. And I'll keep an eye out for your answers. I hope all of you are able to access this mentimeter.com. Okay. Okay, I'm beginning to see some responses coming in. Fantastic. Any more responses? I'm looking at the Zoom chat. I'll read out what people in the Zoom chat have typed out in a moment. So I'm going to give some time for the participants to type your answers. Maybe I'll just bring it out right now then. So one of you wrote about clinical perspective, animal and human health, honesty, punctuality. One of you wrote animal care, subject consent, IRB. When I'm looking at the Zoom chat, I saw a few other issues like plagiarism, privacy, patient's vulnerability. Anything else? So someone wrote here, the study should not cause any harm and any concern should be taken care of. Is there anything else? Okay, let's just move on and then we'll come back to this in a moment. Very good. Thanks for participating, by the way, on this activity. So now we've kind of understood what is the difference between moral, the laws, and ethics. Again, ethics, it's about decision making. Ethics is about, given our circumstances, what should you do? But what about medical ethics? Where does medical ethics come from? In the next 2 minutes, I'm going to give you a really quick overview of a history of medical ethics principles on where did it come from, right? The notions of dealing with human subjects. And it started off from 3 different time period in the last century. And it started off with the Nuremberg Code in 1947, to Helsinki Declaration in 1964, and then the Belmont Report, which was written in 1978. The Nuremberg Code, as you see on my screen on the left side, came about immediately after World War II, where it was discovered that the Nazis of Germany were conducting research on human beings. And it was a pretty cruel period of time. And a lot of the horrendous act was discovered. So many of the scientists, researchers were put on trial for war crime on humanity. And later on, the Nuremberg Code was written in response to the trial to spell out how researchers should behave when we are conducting research with human beings. Several years later, a group of medical doctors went to Finland, Helsinki, and they refined and elaborated on this code of ethics on human research, and they came up with the Helsinki Declaration. And then later on, about 15 years later, the Belmont Report was written in America, where again, they looked at the code that was written before that and refined it even further. Now, if you looked at the Nuremberg Code, the Helsinki Declaration, and the Belmont Report, you begin to see some common themes, some common ideas. And as I'm looking at your Mentimeter, and I see some of the themes already came out. If I were to boil it down to two principles of medical ethics, and this is a really distilled, streamlined thought, would be respect and safety. In respect, we talk about how the research subjects, the human being, make their own decision, and this is the word autonomy. And also privacy, how do we respect their privacy? Respect their private data, for example. Respect their information. As well as the term informed consent. And I'll talk a bit more about this in the next slide. The second pillars of medical ethics is the idea of safety. I think we can all agree that safety is very important to protect the subject that you are researching on, to weigh the risk and benefits. Is there a risk? Yes. I mean, many things that we do have risk. But is the risk outweighing the benefit, or is the benefit outweighing the risk? So this is something that we as researchers need to think about when we are doing research with human beings. And of course, in doing research with human beings, we have to make sure that our research is designed properly. We are using the right methods, the right tools, the right intervention for the patient subjects. So respect and safety. And I think this is a common sense that many of you are familiar with. But let me just go into deeper about this idea of safety issue. In most research institutions, medical schools, there is an entity called the Institutional Review Board, IRB. Again, I saw some of those terminologies in the Mentimeter and Zoom chat. IRB is made out of a group of scientists, researchers, and medical doctors. Their role is to look at proposals that propose to conduct research on human beings. Any research that you want to conduct on human being has to be reviewed by the IRB. Sometimes you might be even doing classroom research. So this is a proper research study that you're doing with students. You also need to have IRB. So what does IRB look at? They looked at protocols, safety, and expertise. Is your protocol designed properly? Are the safety of the people deliberated and thought about? And the expertise of the people conducting the research, are they well trained to conduct and carry out those research? And very importantly, if you want to do a research on human being, you must make sure that you have the right ethical approval before you begin. So you're not allowed to conduct a research on human being until you have received your ethical approval. So this is what Institutional Review Board. So I'm very curious how many of you have gone through the process before, how many of you have actually done such your research on human being. You can leave a comment on Mentimeter. Normally I would say leave a comment on Zoom, but most of you are not in Zoom, but you can leave a comment in the Mentimeter and I'll try to scroll through it and look at it at some point today. So moving on to the next part of ethical issues on human subject research is the idea of informed consent. Informed consent is a document. It could be a piece of paper. It could be electronic on a computer that tells the human subjects what is the research is about, what are the objectives, what are the protocols, what are the safety issues, what are the potential risks, what are the potential benefits that the participants need to know. The informed consent should be easily understood and clearly explained, especially if you have people who may not understand the language that we use in research. I'm not just talking about whether it is in English or in other language, but I'm talking about the scientific words that we use. Have to make sure that the patients, the research subjects can understand the content of the informed consent. Again, if you would like to do a research with human being, you are not allowed to begin with the patient unless you have received the consent from the patient. When the patient signed the document and say that, yes, I agree to take part in your research, then only you are allowed to collect samples, give them a survey, do some brain scanning on them. Okay? So these are the two main topics I want to cover today in a 1-hour lecture on human subject research, which is the idea of informed consent, and also in the idea of the institutional review board. Now, let me switch gear a little bit. Once you have collected your data, where do you store your data? So now we're going from dealing with patients, doing research with them. But now the question is, once you have collected those data, and I'm not talking about specifically on human subject research. I'm talking about your research. So there are 200 of you listening in today. All of you, I hope, are doing research and you are collecting your data. I'm very curious, where do you store your data? If you still have access to the Mentimeter, and I'm going to put it out here, you can still go to the same page, menti.com, and type in the code 3303303. And just leave a comment, if you can, on where do you store your data? So I'll give you 30 seconds to think about this question, or write it on a piece of paper, or leave a comment in Mentimeter. Okay, so I see some comments. People say that they have conducted human study before. Fantastic. So someone in Zoom wrote that in the office cupboard, some kind of file, when you open your cupboard, there are some documents in the file cabinet. So some people store it there. Someone also wrote in a computer, in a PC, in a hard drive. Someone wrote in data repository in Mendeley. Okay, notebook, laptop, screenshots, personal hard drive. I see that in Zoom. Thank you very much for responding to my questions. Okay, very good. Any other ways that you store your, how about in a phone, okay, as a picture on your phone? Someone store it on a cloud system, Outlook. Google Drive, cloud system. Nowadays, a lot of us use cloud system to store our data. Fantastic. So, just looking at around and where we store our data. Many of us store our data on a computer, in a hard drive, or in a thumb drive like this in the middle, the small thumb drive that we can carry around with us wherever we go. Just plug it in, save the data, walk away, and you can analyze the data anywhere you want. And today, more and more common, many of us store our data in a cloud system. So everything goes to the cloud. Google Cloud, Microsoft Cloud, Apple Cloud. There's all kinds of cloud where we can store our data. Now, the question for you that I have, well, that also includes the hard copy, right? I don't want to ignore the files, the folders that you keep in your offices and in your cabinet. My question for you is this: how secure is your data? Where do you put your thumb drive? Where do you bring your laptop to? When you store in a cloud, how strong is a password? Is there a possibility that the cloud storage might be corrupted and deleted? Do you back up your data? So those are the questions that we have to think about when you are dealing with data, especially when the data contains sensitive information. So the reason why I talk about this issue of research data management when before that I was talking about medical ethics is because these are related. Because when we talk about research in human beings or research in any form or shape, there are many issues in research that we need to think about. And I'll just spend one slide to talk about it because this topic alone can be a 1 hour lecture on its own, which is the idea of research ethics in general. Thinking about various aspects of research, for example, I just mentioned data management. Where do you store your data? Who do you share it with? Do you put it on Facebook to share with other people? Do you go to a presentation and show everyone your data when you have confidential information? How do you share it? And we briefly mentioned, someone mentioned it in the Zoom chat on the idea of plagiarism, on research misconduct, about the honesty of reporting and collecting data. The idea of bias, of objectivity. Sometimes when we do research, the biasness may influence our judgment. Maybe it is due to a conflict of interest may affect how we perceive and how we analyze data. As well as the idea of publications. For researchers, we need to publish our research findings. So where do we publish them? And how do we publish our data? And last but not the least is the idea of social responsibility. We as researchers, we have a responsibility towards the society. Yes, we do research in our laboratory or out in the field, and we have to make sure that we do our research properly. On the same time, what is our responsibility towards people outside of the research ecosystem, the general public, the environment, the policy makers, right? The people who are selling a plate of rice on the street. Is our research being responsible, and are we taking care of our social responsibility? So these are just some ideas that we need to think about as researchers, as thinking about medical ethics. So moving on, now I'm going to just spend the next few minutes to talk about the idea of ethical issues in neuroscience research. Again, going back to menti.com, the code is 3303303. I think I see a few more people currently inside here. Again, I'm going to show you this menti.com. You can continue to type your information into this Mentimeter. And the questions I would like all of us to consider together is this question. Neuroscience research with human have unique ethical considerations. We talk about some of the ethical issues that we need to think about in medical research. Think about issues when we are just doing research in general. But now I would like to switch gear a little bit and talk about neuroscience research. Since this is an IBRO event, IBRO class, let's think about neuroscience. What are some of the issues that we need to think about when we're doing neuroscience research with human beings? Again, I am going to give you about 1 minute to reflect on this question. You can write it on a piece of paper, or you can write it on Mentimeter, or you can write it in Zoom. So I'll give you about 1 minute to think about this question. Any thoughts about this question? What are some of the more unique ethical issues that neuroscience research in human faces? Okay, I'm beginning to see some information coming in. So someone wrote here, I guess I can put this over for you all to see. Someone wrote here, recruitment and retention is a major issue when talking about neuroscience research. I'm very curious, the person who wrote this, why is it a particular major issue in neuroscience research? So the person who wrote this, if you can comment on why is that the case. Okay, so I see here some other point, consider the consent. Make sure the safety, family consent also. So the idea of consent also came up. And here we have the idea of patient mental health and patient consent. This is a very interesting topic, right? We'll talk about this in a minute. Any other thoughts? I want to hear from this person who wrote this, this idea here. Retention of subjects is particularly difficult. Any other thoughts? Okay. So there's a new comment that just came in. And again, it says here, it's the perspective of safety, privacy, ethics, and human. It's not just in neuroscience research. I would say that it is in any forms of human subject research. Someone in a Zoom chat wrote that there's a reluctance from patients. Okay, I'm very curious to know why are patients reluctant towards neuroscience research? Is there a particular aspect of neuroscience research that make patients a bit more reluctant? So again, leave it in the comment, in Mentimeter or in Zoom chat. Okay. Any other thoughts before I move on? Okay, another new comment just popped in. It says that the patients are reluctant because of trust issue. This is a very key thought here, right? The trust issue. So the question is, why are they so reluctant? What is the trust issue that patients are unwilling, right? This is again something to think about. Okay. Yeah. So I'm seeing some comments, so I'm gonna just move this away and just explore this topic together. It is true that whenever we talk about research with human beings, the idea of privacy, the idea of trust, the idea of safety will always come out. And it's also that issues of whether patients trust us as researchers. And those are all true, and those are all really relevant to you and I as researchers. But let's think about the idea of neuroscience research. Again, full disclaimer, I am not really a neuroscience researcher. But I just want to think about how some of the challenges that neuroscience researchers faced and how that is related to the idea of ethics. So let's look at three areas. Let me just pull it out. Well, 4 areas. Number 1 is the idea of brain and mind connection. We will talk about it. What does that mean? Number 2, in neuroscience, it's particularly special relationship between the researcher and the human subjects. I think that idea is sort of brought up in a Zoom chat as well as Mentimeter. And also in neuroscience research, the measurements of short-term and long-term effects can be quite challenging. Again, I think this point has been mentioned in a Mentimeter and Zoom chat. And finally, but this is not the last one, is how do you deal with subjects with limited cognitive abilities? So let's think about this question. The brain-mind connection, right? I think the brain is an organ that we are all very familiar with, but the mind, it's a bit more abstract, isn't it? It's about emotion, it's about thinking, it's about memory. So when you are doing research on skin diseases, for example, I give you an example, skin disease. You give a drug, the rash goes away, the itchiness goes away, or the pain goes away. Great, well done, right? You have successfully tested your drug and the patient is happy. But when you are dealing with neuroscience research in human being, on dealing with issues like anxiety, depression, cognitive behavior, there is a deeper level of aspect, which is the mind. You are not just manipulating the brain, the neurons, the tissues, the brain cells, but the thinking process of a person. When you are manipulating the brain, you are also potentially manipulating the mind. You're also potentially affecting their thoughts, their memory. So there's a brain-mind connection that I think is particularly more prominent in neuroscience research. The same can be said for something like brain imaging or imaging research. If you were to image a person's brain to look for unusual growth or tumor, for example, you do a MRI scan and you see the tumor, or do a CAT scan. So you see a tumor, you know there's a cancer. But what about brain imaging to understand thoughts? Imaging to talk about motivations, to think about depression again, right? Are those thoughts private? Are those thoughts supposed to be private information? What if someone have a thought that when you scan, you see that thought that you were not expecting, and which is not related to your research? Is that thought considered private information? Because brain imaging sees, how your brain processes information. So again, without going much further into this idea, I think that one of the ethical issues in neuroscience research is a connection between the brain, the mind, the memory, the thoughts, the emotions, right? So those will always come into play when we are doing research with in neuroscience. And because of that, the short-term and the long-term effects, it's a bit more difficult to measure, right? For example, when you are doing, say, a skin disease research, you treat the patient, you see that the rashes goes away, you are considered quite successful. Or maybe, let's say, tumor, you do a surgery, you do a radiotherapy, the tumor shrunk and disappeared, great success for you. But in neuroscience research, again, going back to the idea of brain and mind connectivity, when you were to do research on a human neuroscience, sometimes the long-term effect is still not very clear. What would happen 2 years, 3 years, 5 years down the road with the human subject when you have conducted research on them? Sometimes it can be also not very clear. For example, in some psychiatry, in some psychology research, they want to understand, they want to create a scenario. If you're very curious, you can look it up. This is the Stanford prison experiment, where they want to understand human behavior. So this is an aspect of neuroscience also, right? Even though it is psychology. But in that research, they put human beings under certain circumstances which are not very pleasant. And years later, those participants who took part in that research still experienced that negative effect of the research which was conducted many years ago. So the long-term effect in neuroscience research, it is still quite unpredictable. And because of that, there's also a special relationship between the researchers and the human subjects, right? Because going back to the whole idea of the mind and the brain connection, I think that the emotion connection between a neuroscience researcher and a patient might be a bit stronger when you are doing some kind of neurological intervention, counseling, psychology or psychiatry intervention. That connection, in my opinion, seems to be a bit deeper, a bit more profound than other kinds of research. Again, so this is another point I want to bring up. And last but not the least is the idea of subjects with limited cognitive abilities. What do I mean by that? For example, those patients that have Alzheimer's disease or Parkinson's disease or Huntington disease, where they are having neurodegenerative condition. Are they able to understand your informed consent? Are they able to give you agreement to do research on them when they themselves have limited cognitive abilities? What about research on minors, on children underage? Are they able to give you consent to do research on them while they are still growing up, while they still do not fully understand what is going on? So how do you deal with this kind of situation when you have the minors, people with mental disability? How do you deal with that? All right. So again, this is another level of ethics that we need to think about. And this issue is not only in neuroscience, but also in all kinds of research that we conduct with human beings. So as researchers, how should we handle this kind of situations in neuroscience research? Again, my goal today is not to give you the top 10 answers of how you should do, but more to give you the right mindset, the right framework to think about what should I do in this situation as an ethical researcher. I have already mentioned about respect and safety as the two pillars, right? I would like to add another dimension, which is the research ethics. Just to highlight a few, I'll talk about data storage, professionalism, honesty, transparency, publications, authorship. Those kind of issues are also part and parcel of how we as researchers need to think about when we conduct research, not only on human beings, but just doing research in general. Okay. So I would like to cover a few more topics, and these are the topics that I don't quite know where to fit into the idea of neuroscience and ethics, but I thought it is worth considering, worth pondering about. We are moving into an era of artificial intelligence in neuroscience. We are moving into an area of computers, right? Being so smart today. I don't know how many of you have watched this movie from a while ago called I, Robot, with Will Smith as the lead actor. So those robots have artificial intelligence. Those robots were designed to recognize human emotions and feelings and make decisions for us. What about self-driving car that is being developed today? There's also some elements of neuroscience being put into those algorithms, those computer systems. What is the ethics of those instruments? The same ethics that governs human behavior, does it apply to artificial intelligence? Something to think about. Today, our world, we can't run away from the big computer companies, Google, Facebook, Apple, right? Amazon, Microsoft. I think it is no secret that these companies are constantly collecting our data, collecting information from us, studying our behavior, studying how much time we spend on Facebook, what kind of websites we go on Google, and those information are constantly collected. And sometimes those companies will also work with academics to conduct research on human beings. What are the ethical dimensions in those situations when Facebook want to collect a data from you about your behavior? And again, relating it to neuroscience. What about criminology in crime scene investigation, in criminal justice law? Again, I want to use this movie as an example movie by Tom Cruise called Minority Report that came out, I think, 10 years ago, where they applied neuroscience to solve crime. Today, I think in my last reading, perhaps in a court, you can put a subject under a scanner, look at the brain, ask them a few questions, and then you can see whether they are honest based on how their brainwave work, whether they have committed a crime or are they not, or are they guilty or are they not guilty, using neuroscience brain scanning to solve crime. Where is the line between a privacy of my thoughts versus whether my thought is really incriminating towards me as someone who is being trial in a court? Again, the whole idea of neuroscience and criminology here comes along. And last but not the least, we haven't had time to talk about this, which is neuroscience research in animal. I don't know how many of you do research on animal, but again, animal research is a very vital aspect of neuroscience research. When we look at drug testing, Parkinson's disease, Alzheimer's, behavior study, we constantly use animal. And to do research on animal, we also have many levels of ethics on animal handling. So I have come towards the end of today's talk, and I know in the last 45 minutes, I kind of went through really quickly within the time frame to start from really broad, talking about ethics, the laws, and the moral values. We begin by exploring the concept of when you are faced with decisions to make, how do you make those decisions? And that's where ethics come in. And then we apply that into medical ethics, into what are some of the key areas that we have to consider when we are dealing with human subject research. And then we compare and contrast between medical ethics and research ethics. And then finally, in the last 15 minutes, we explore the idea of neuroscience research, thinking about what are some areas of neuroscience research which make it a bit more complicated when we are doing research with human beings. So I hope you all have learned something today. You have gained some insight into this idea of ethics on general, as well as ethics in neuroscience. So what is the key messages here? I would like to leave with you some key points to think about. No matter where you are in the stage of your research career, whether you are the PhD, a master's, or undergraduate students, whether you are a professor, whether you are an early career researcher, a lecturer, we all have a role to play, right? Because ethics is a foundation of building trust. I think someone wrote in the Mentimeter that there's a lack of trust. Why is there a lack of trust? And how can ethics rebuild that trust in the community? And that comes from all of us here, you and I, as students, as researchers, as academic leaders, we all have responsibilities to play in fostering research integrity, not only in the way we do research in our laboratory, in our animal room, in our cell culture facility, but also in the public, with the society, with the community. How do we make integrity as part and parcel of the way we do research? And finally, I want to leave you with this point, which is a healthy research ecosystem, healthy society. If our research ecosystem is healthy, where there's integrity, it's ethical, the work that we do can truly bring an impact to the community around us. And therefore, by that, we can improve the health of the society. So with that, I want to thank all of you for listening to my talk today. Thank you so much for engaging with me via the Zoom chat as well as the Mentimeter. It is a pleasure for me to read your comments. And once again, thank you so much to the organizers for inviting me to give this talk today. Dr. Sada, back to you. I think we have some questions.
Yes, the floor is open for question. If you have any question, you can unmute yourself and ask here if anyone wants here directly. But on our YouTube and the Google form, we have one question for you, Dr. Deming, that will it be ethically correct? The patients with neurological or psychological defects might have gone through certain trauma, or even that has now become a strain to their well-being. So the patient provided with interventional neurological moderators to ease their pain or trauma and dampen their memories. So is it ethical to do in this way or not?
Yeah, so I think thank you for the very profound question. Again, I just want a full disclaimer that I am not a neuroscience researcher, so I can't fully answer your very specific questions on whether this type of research should be ethically acceptable or not. But I think I want to provide the basic principles in thinking about this question. The idea of safety, right? If the safety of the patients being looked into, is the safety of the patients well protected, and as well as the informed consent. Patients who have gone through trauma like that, sometimes they may or may not be able to fully give consent, which is why the idea of legal guardian will come in, which I haven't had time to talk about, where someone who is legally appointed to provide consent on behalf of the human subject. So I think those are the basic principles I want to share without going into specifics of whether a particular research should or should not be carried out.
Okay, thank you. Next question is from Dr. Shalina Bhimani. She is asking that what about consent for intrauterine fetus?
Yeah.
It's extremely crucial to study fetus, and what about the fetal engagement ethics?
Yeah, I mean, this is again such a wonderful question, right? You want to do research on fetus, but fetus does not give consent, right? So what do you do? I think, right? So I think this is something that we need to think about, is that in this kind of situation, who is the one that gives ethics? Of course, we can't get ethics from the fetus. Therefore, the ethics approval, I mean, the consent would have to come from the mother who is carrying the fetus. Again, so I think that's where the informed consent comes in, right? It will come from the mother, the legal guardian of the fetus. Yeah, so I think that's how I'm not quite sure about fetal engagement ethics. This is something that I have not looked into yet, but such an interesting question that I should think about.
Next question is about that during medical neurological researches and areas where innovations are progressed to explore memory revival. So what boundaries they must lie in?
I think this question came out somewhere in the Mentimeter, right? Memory revival. This is such an interesting question again on a memory revival of, if I were to understand your question correctly, someone has maybe experienced something, but that memory is somewhere in the brain, but the person don't remember anymore. But now you conduct a research that sort of stimulate the person to remember the memory. I guess I can only answer this with some rhetorical question. What are some of the potential risks of doing this kind of work? Would that cause any harm to the person that you are conducting this innovative research on? If there is risk, if there could potentially be harm, then my question for you is that, are you prepared, or is the patient prepared to deal with it? Are they fully informed of the potential risk that this research may bring?
Okay. Dr. Deming, the next question is that is in the case where there is an equal ratio of risk and benefit involved in the study. So what should be prioritized, to go for the study or to exclude human and move for the animal study?
Such an interesting question. If there's equal risk and benefit, right? Normally, when we do research, we want to see benefit outweigh the risk. We want to see a lot of benefit, very little risk, then we'll go forward. Now, you present a very interesting question, which is what if the benefit and the risk are equal? In my own personal opinion, this is a personal opinion, I feel like a research like this should not be carried out because the risk does not justify the benefit. For example, if I were to give you a COVID-19 vaccine today, and I tell you you have 50% chance of getting a side effects, of a severe side effects, you probably would not go for it, right? 50% chance. But if I tell you the risk is 0.000001%, you'll probably say, sure, no problem. So I think 50% chance is not significant enough to go for it.
One question is from the Google form where the participants are asking that as a matter of fact, we can replace human with robots now. But can we really inbuild human emotional conscience and intelligence and feel in them? And is it ethical?
This is such an interesting question. Again, we're going into the advanced technology, right? Whether we can, I think this is not the scope of today's discussion because I'm not a neuroscientist. I think this is where brilliant scientists like you in Pakistan or around the world are trying to understand today, right? So congratulations for all of you about thinking about this kind of questions. Can we? I'm sure we can if enough people put our brain together to solve this problem. Yes, we can. Was it challenging? Of course, it is challenging. And ethical issues, will we encounter? Yes, we will encounter it. In any research that we do, from 100 years ago, we had ethical issues. Today, going forward, 50 years from now, we have no idea where research is going today. We have no idea how robots going to be like 50 years from today. Therefore, I think it is so important that we start from today to think about the ideas of ethics. Where is the boundary? How much autonomy should we give robots? How much power should we let robot control our life? I don't have an answer for that, but I think for all of you who are listening in today, I hope today's talk will spur you to start thinking about those questions as you move forward into this very exciting neuroscience research.
Okay. One more question from Ms. Yusra Salim is that, are we actually looking to maintain balance between moral and law, or it's individual idea, or is there a correct answer to the first example that you gave?
Yeah, the idea of moral and law is a distinction. Very often you will find the answer is yes and no, right? Very often you will see that laws are based on morals. The laws that we have today: do not steal, do not cheat, do not rob, do not kill. A lot of these laws were based on perhaps religious law, right? Religious understanding based on the Bible, based on Quran, or based on all kinds of religious document. So there is a lot of overlap between that. But yet at the same time, there are a lot of things in the law which are not mentioned in our moral books, or not written in our religious book, which are separated. So those are quite distinct. Pertaining to your question about how should we behave in my first example, to be very honest with you, I have conducted this survey with many people just to see what they do. It's always 50-50. 50% of the people say they will go, and they justify because we don't want to cause harm to the mother who is about to give birth to a baby. And then 50% of the people say that they will stay because they don't want to break the law. So yeah, I'm not going to tell you what you should or should not do, but I think this is something that we have to apply our own judgment and make the right decision based on the situation.
Thank you so much, Dr. Deming, for all the enlightening examples and the talk and the interactive session as well. Because till now, we had the tutorial sessions, which were very interactive. But we only had the keynote talk, but not that much interactive. So thank you so much for engaging us and just discussing these basic things that a human researcher should consider, and as well as the animal research, because we have the participant from both background, the clinical background and also the basic science.
Great.
So students are also asking about the animal research aspects as well. We will be very glad if we will receive any further question. We can just send it to the Mentimeter and you can just have a look at it.
Yeah, actually, I'll keep the Mentimeter turned on, or if they have any questions, they can email to the organizers, and organizers can forward it to me, and I'm happy to answer those questions.
Sure. Thank you so much. Thank you so much.
Okay. Thank you very much. Thank you so much.
Bye-bye.
Take care, everyone. Bye-bye.
Now we are moving towards our next talk by Dr. Shelina Bhimani. Thank you, Dr. Shelina, for joining us and being there with us throughout the talk with Dr. Deeming as well. Let me introduce Dr. Shelina Bhimani. She is an assistant professor at Aga Khan University Hospital, Pakistan. Dr. Shelina has completed her PhD research on early childhood development program monitoring from the Institute of Business Management, Karachi. She has worked as regional assessment manager at USAID and is serving as assistant professor. She is specialized in monitoring, evaluation, and research, social advocacy, and early childhood development. Dr. Shelina is one of the known persons who is doing a lot of research and advocacy related to early childhood development, and our purpose to invite her here is our concern that can connect you that how early childhood development and all the development can affect towards the well-being and the progression of these neurodegenerative diseases. So thank you, Dr. Shelina, for joining us. Over to you.
Thank you, Dr. Sadaf. Can you hear me well?
Yes, perfectly fine.
All right. Oops. So due to technical issues here, what I'll do is that I've signed in from 2 accounts and I'll share my presentation. Pardon and apologies in advance. So if you could allow me share screen, I can.
Yes, you are allowed.
If you can see the screen, can you please type 1 in the chat log? I'm requesting the participants do that. Great, let's just go ahead.
Hi everyone, thank you so much for attending this session. Today, I'll take you briefly through this very important component on early life markers and factor affecting neurodegenerative disorders. We've always traditionally and conventionally seen neurodegenerative disorders to be the disease. Hi everyone, thank you so much for attending this session. Today, I'll take you briefly through this very important component
Dr.
on
Sadaf,
early
is my
life
presentation
markers
clear?
and factor affecting neurodegenerative disorders. We've always traditionally and conventionally seen neurodegenerative disorders to be the disease of old age. Hi everyone, thank you so much for attending this session. Today, I'll take you briefly through this very important component on early life markers and factor affecting neurodegenerative disorders. We've always traditionally and conventionally seen neurodegenerative disorders to be the disease of old age or to be the disorder which is identified at a very later stage of life. However, in order to explore the roots of neurodegeneration, it's very important to go back to the earliest years of life. And hence, today I'll take you through all those stages of early life and together with you explore different factors that contribute to neurodegenerative disorders. So welcome once again, and let me just take you through this brief presentation. Before we could proceed, I'd like to present a disclosure that I do not have any financial or personal benefit. Pictures are taken from open sources, and I'm taking it as just a learning exchange forum. Hence, whatever I'm sharing, probably down the lane in next couple of years or maybe couple of weeks, the evidence might alter or might change. And hence, we should all take this as exploratory learning opportunity. Thank you so much.
So the objective of today's session we'll be understanding various factors that impact neurosciences and neurodegeneration specifically. Also understand the significance of 3 human stages for early intervention and neurodegeneration prevention, and how do these 3 stages of human lifespan development actually impact or predict neurodegeneration: prenatal, postnatal, and early childhood. These 3 are the most crucial and most significant period of human life. And I will take you through different theories as well that talk about and that put evidence forward to see how these 3 stages actually determine or predict any sort of diseases for the later life.
Before getting started, I'll count till 10 and would request all of you to please write one word that comes in your mind when you look at the picture on my right. So on the count of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Please write one word that comes to your mind when you look at this picture. And let's see what are the responses.
Excellent. So I can see in the responses that you've written personality development, complex brain, mental wellness, brain functions. Absolutely. So these are the few of the indicators pertinent to neurosciences, or you can say brain development, that you'll be hearing throughout the session. And we'll see how all of these connect together in order to predict or start an early intervention for neurodegeneration.
It is extremely important for everyone to understand that health is an inclusive phenomenon. Health is just not a medical science. Although with the recent developments and advancements, much has been done to ensure integration of social, environmental, behavior, and economical determinants of health, but still it's not enough. Samuel Wilson, in his quotation, has very interestingly mentioned that the infrastructure for linking environmental health and public health is not working as well as it should. So this tells us that if we want to study any phenomenon in health, it is utmost important to study all the determinants and how genetic and environment both play an equal role in ensuring health and well-being of any individual. Let us just see this short video and understand what are the different determinants of health.
Health. It's the state of complete physical, mental, and social well-being, not just the absence of disease or infirmity. And good health is something we strive to achieve, not just individually, but also as a community. But if we look around us, our family, friends, and others, we know that health is very variable. For example, in 2016, the life expectancy of a child born in Sierra Leone was 53 years, while in Australia, it was 83 years. But even within Australia, the life expectancy of Indigenous people is about 10 years lower than that of non-Indigenous people. And even within a specific group of people, health can change based on a person's income, level of education, or occupation. So why is health so variable? To answer that question, we must understand the factors that influence health. The factors that influence a person's health are called determinants of health. These include who they are, such as age, sex, and genetic makeup, and what they do, as in health behaviors such as smoking, physical activity, alcohol use, and diet. Health is also largely influenced by the conditions in which people are born, grow, live, work, and age, collectively called the social determinants of health. The social determinants of health are shaped by the distribution of money, power, and resources at an international, national, and local level. These can lead to health inequities, which is the difference in health between different groups of people that is unfair and avoidable. Let's take a look at the social determinants of health using a framework developed by the World Health Organization. According to this framework, there are two broad groups of health determinants: structural and intermediary. Structural determinants are the socio-economic and political context that people live in. It includes governance, economic, social, and public policies, and also the social and cultural values placed on health issues. These factors can lead to the unequal distribution of material and monetary resources, which can shape a person's socioeconomic position. Socioeconomic position is characterized by education, occupation, income, gender, race or ethnicity, and social class. The structural determinants of health operate through a set of intermediary determinants that impact a person's exposure, vulnerability, and outcomes to factors affecting their health. These include material circumstances, such as the quality of housing, the financial means to buy healthy food, clothing, or other requirements for healthy living, and work environment. Psychosocial factors, like stressful living circumstances, relationships, and social support. Behavioral and biological factors. In addition to these, health systems determine the type of healthcare, the quality of it, and how easily accessible it is. Bridging the structural and intermediary determinants are social cohesion and social capital. The links between all these determinants are not always linear, but can be complex, interdependent, and interact in many different ways to influence health. For example, poor income can limit opportunities for achieving good health, and conversely, poor health can limit opportunities for people to participate in the workforce. And remember, these determinants can act across the course of a person's life. So, the next time you think about a health issue, consider not only who they are and what they do, but also the conditions in which they are born, grow, live, work, and age. Because if we understand and act on them, we can build a healthier world for everyone.
So may I request Ujala to please put a poll? Based on this video, I would like you all to rank. What do you think impact the health most? So Ujala, over to you if you can run the poll here. What, in your opinion, is the most influencing factor of health? Let's just see it from you all. Ujala, can you share the results with us as well? So on the count of 5, let's stop the poll and see the results. 1, 2, 3, 4, 5.
Dr. Shalina, you have to stop sharing your screen so that we can share the results. Thank you.
Perhaps to save time, we can use a chat log. If you can tell me, which do you think is the most influencing factor? Do you think it's environment? Do you think it's genes? Do you think it's the physiological health? Or do you think if it's education or if it's socioeconomic status? So on the count of 5, let's write in the chat log, what do you think is the most influencing factor that can have an effect on our health? Oh, we already have the results. Thank you, Dr. Sadaf. So most people rated environment, 19% rated genetics, some talked about, 0 talked about medicines, interesting. 6% talked about pathologies, 6% talked about social status, and 6% talked about education. We'll review your thoughts maybe at the end of the presentation. Thank you so much, Ujala. Let me just go back to my presentation.
Let's quickly go through neurodegenerative disorders. These diseases affect millions of people worldwide. These disorders include a broad range of conditions that result from progressive damage to cells and nervous systems connections that are essential for mobility, coordination, strength, sensation, and cognition. Its progression can lead to altering the capacity of mobility and balance, abnormal movements, swallowing, bladder and bowel functions, blood pressure fluctuations, sleep, breathing, heart function, memory, and cognitive abilities, mood, and speech. Internationally, it's said that 17% per 100,000 ratio is a ratio of neurodegenerative disorder, which is huge. And it's very unfortunate that to date science has still been sort of like planning therapeutic interventions which start from the later age of life, whereas the research needs to further grow to find out the roots of neurodegenerative diseases and disorders. There are a few very common types of these disorders that all of us know, like Alzheimer's, Parkinson's, AL, retinal degeneration, and like so. So the neurodegenerative disorders can be classified clinically, and they are also classifiable histopathologically by the nature of the proteins that are accumulated in the brain and how they are distributed. So clinically, this disease overlap, and pathologically these disease overlap, which makes them so difficult to study, and there are very few limited diagnostic tests available to do so. Neurodegenerative diseases are a heterogeneous group of disorders that are characterized by the progressive degeneration of structure and function of the central nervous system or peripheral nervous system. They are clinically heterogeneous, they are pathologically heterogeneous, they are ideologically heterogeneous, and they are disease of aging. So there is a long preclinical period that the exposures that we are interested in may have occurred decades before the symptoms present, which makes them really hard to characterize, and also it's very hard to determine the competitive mortality. So when people who have got an underlying disease process might die from some or the other competing cause before that disease manifests. Hence, it's vital to study the early environmental and other related factors way before the onset of the disease occurrence. And being an early childhood development enthusiast, I would like to take you through the school of philosophies who believe that developmental origins in health and disease can be tracked or determined the moment mother conceives. So if the earlier we intervene, the better it is to identify and to provide therapeutic treatments. So onwards presentation, you will see that the entire argument is based on understanding what are the early factors, what are the early environmental factors and social factors that influence or impact neurodegeneration from the start. So, when the disease occur on set, we know what has been the history.
May I request all of you to kindly put down in the chat, what do you see in this picture? Like, what is this in the picture? So let me count till 10 and then request you all to please put down what you see in this picture, every single thing that you see. On the count of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, most of you have written social network, technology dependence. I would still request you to closely look at it and look at the other factors as well. Do not just go on reading the billboard. Look at the other factors that's there. Noisy, excellent. Noisy. You also see a lot of buildings, environment, excellent, trees, water, sun, there are clouds. So environment, heavy, rich environment is what is one of the most influencing factors of neurodegeneration, and we shall further study how.
Before we jump on to understanding all the factors that contribute towards environmental determinants, it's very important to understand what environment consists of. It consists of the food that we eat, it consists of the interactions that we have, it consists of the lifestyle, it consists of pollutants, it consists of metals, microorganisms, the quality of communism, peace, quality of health. All of these factors are composite or composite environment, and all these factors play direct or indirect role in brain development or the holistic health and development of any individual. As you can see in the pictures on this slide, it's very important to understand the early origins of the environmental factors and other factors that contribute to ND. So it's basically very easy to understand if we just take one sentence as the basis of everything, that it's an interplay between the gene and the environment, and both contribute in its onset and progression. So it is important to closely study its origin, starting and focusing on the in utero, starting from the moment mother conceives and slowly seeing and slowly monitoring the trajectories of every individual, and also critically reflecting on how prenatal, postnatal and early environmental factors are also one of the major contributors and the root causes of developmental origins of these health and diseases. Similarly, if you see that NSP's mediation and gene-environment interaction, just like that, during these factors play a key role in susceptibility to any disease. And like so, it falls same for the neurodegeneration. In some cases, it's hard to explain neurodegeneration by looking at the family history, but we surely have chances to track the development of what's happening around that child and consider how the later life outcomes would be and predict or what, and we can always ask the questions like what triggers that remains unexplained. Hence, it's important to study these disease in context of early environmental exposure, because the moment we diagnose that A person or B person has Alzheimer's or Parkinson's, we become too therapeutic, we become too agile to sort of or too involved in sort of treating that. But it's very important to significantly study the roots of it, because everything, as per a few models we'll study, that those models talk about how developmental origins, how tracking early from the prenatal stage can actually help track a lot of disease before its onset.
So if I'm to ask you a question, where do you see the intervention to begin? At the prenatal stage, at postnatal stage, or in early years? If you really have to talk about brain sciences, neurodevelopment, neurodegeneration, where do you think the first intervention should be? Can you put that down in the chat log? Should it be in the prenatal stage? Should it be at the postnatal stage? Should it be in the early years? Okay, I can see some are saying early years, some are saying prenatals. Okay, let's just study where and how and what sorts of intervention, and especially where it should begin. Let's just study further.
There are several models that discuss about why it's important to study these periods of life. So the first is FEBA, that's fetal bias for adult disease. According to this model, they have done a study that they have tried tracking the cardiovascular diseases in the early origins of fetal and how fetus gets adapted to environment, and it's totally dependent on the environment. So disease are more or less, according to them, disease are more or less consequence of fetal adverse condition. Fetus gets adapted to new environment depending on environment stimuli in the uterus. So whatever happens during the pregnancy time is actually what impacts the later life outcomes as per FEBAD. Dohad then came as like one of the modified theories of FEBAD, whereby they postulated that postnatal period also play equal role. Adaptive response during different developmental stage has a great role in neurodevelopmental outcomes as well as neurodegeneration. They also argue that environmental condition in infancy phase exert their influence on genotype and alter the ability to cope in the later life. Similarly, PAR, predictive adaptive response, Gulkman and Henson have suggested that when the fetus is exposed to adverse conditions and stress, makes changes that are irreversible. And many of the roots for neurodegeneration could also be coming from the fetus or the in utero environment. Similarly, Learn model also argued, which is latent early life associated regulation. It talks about how environmental factors impact disease etiology and promotes or maybe contributes towards neurodegenerative disorders. And this come as the latent model that they show, which leads to epigenetic perturbations but don't necessarily impact the disease symptoms, but at least it talks about what makes it more trigger or what allows it to trigger further. And all of these models very closely debate that how and why it's important to study diseases from in utero, from the period of in utero prenatal, and take in account those early years exposures of human life and see how these early experiences of life are contributing to the disease and health in the later life. If we study about the intrauterine environmental factors and how they contribute to neurodegeneration, it's very important to understand that there are factors that contribute. Whatever it contributes to maternal health goes to fetus. So extensively studying intrauterine environment have become focus of the scientists. They started seeing the impact of exposures of heavy metals such as leads, manganese, mercury, the impact of unhealthy diet, stress, intrinsic factors, all of these factors have great potential to alter the regulation of gene exposure. Similarly, intrauterine conditions of how the maternal environment is or the environment in the womb is, that is determined by the environment that the mother is living in. Mother's body is what the fetus is most exposed to. Growth of the fetus is linked with the growth of mother. Maternal constraints can significantly impact restriction, which can limit the size of placental connection between the mom and the child, affecting the supply of nutrients. And because of that, this could also become one of the one of the contributing factors toward the later life diseases. Multiple pregnancy, bad health indicators, high risk modalities, increased age, and short stature are also one of the most studies indicators that have very long-term impact on neurodegeneration diseases. There have been several research studies being done on human and animals where they have traced that how chronic placental insufficiency or hypoxia or heavy metal exposure or hormonal disbalance lead to later life neurodegeneration. Also, there have been evidence in animal studies that talk about female exposed to LPS, a bacteria that shows a loss of neurons, has also impact on the later life neurodegeneration or even early life in animal studies. Also, the gestational exposure to lead has a huge impact on neurodegeneration. One of the examples you can conveniently see is like stress or loud voice or use of drug, how these both very heavily impact the intrauterine environment. In the other slide, I'll show you one of a very short clip that will give you an exposure as to how stress or loud voice has a huge impact on intrauterine environment where the child is living in. And if the child is exposed to regular or organic stress and loud voice, you can imagine the kind of neurodevelopmental delays that child may be facing in future. Or there are more likely chances that those children who are exposed to such kind of high stressors may have later life diseases of neurodegeneration. Let me just take you through that very interesting, very short clip.
As I'll show you this clip, I would request all of you to put down a smiley or a sad face in the chat log after seeing this clip, or even during seeing this clip. I'll play it twice.
Basta! Mi hai stufato! Non ti sopporto più!
Non urlare,
Insomma, basta!
smettila!
Quando un bambino nasce,
Basta! Mi hai stufato! Non ti sopporto più!
Non urlare,
Insomma, basta!
smettila!
quando un bambino nasce,
So you see the kind of environmental factor and how they impact even when the child is not even born. Intrauterine environment cannot be neglected when we talk about brain sciences or neurosciences.
There are some more studies that have been done to understand that what is the significant impact of physiology and metabolism on neurodegeneration, and scientists have found significant impact of that. Also, the new non-communicable diseases (NCDs), which mother or fathers or genetics they have, it also has an impact on not only their but their transgenerational health as well. The fetus and newborns are dependent on the nutrients by their mothers, and if there is an insufficiency of those nutrients, it also has an impact on neurodegeneration. Deficiencies of any nutritive supplements to the mother result in long-term consequences to their offsprings. In 1990s, there have been studies that elucidate positive relationship between maternal diet and neurodegeneration. Vitamin B12 maintenance and myelination in NS, imbalance of micronutrients and antioxidant enzymes. So all of these are intrauterine or prenatal contributing factors that have impact on long-term health of any human being or individual. However, all of these studies have like some implications that they are limited to in utero, and they were not able to track longer term or later life outcomes. These are all retrospective, so there's a recall bias. There is a very a thin evidence pertinent to longitudinal studies. The ones which are longitudinal are not long enough to be justified, and hence there's a huge gap between researching on intrauterine environment and the environment of early childhood years and its impact on the neurodegeneration outcomes or later life outcomes. Just like intrauterine environment, talking about postnatal environment, breastfeeding, provides the best nutrients to the child. If not provided with the exclusive breastfeeding or insufficiency of proper nutrients, children and their brain architecture can face a heavy damage, which can also result into later life and the adverse outcomes. Little children, if they are not provided with simulation, caregiving, immunizations, right nutrients, clean and safe environment, hygienic environment, or high exposure to lead, high exposure to technology, high exposure if you're living in the concrete world like ours, all of these factors contribute to the postnatal environment, and it contributes to the postnatal developmental health, and this in result ultimately impact the later life outcomes of ours as well. So these are also one of the postnatal environmental contributors that may have a potential to impact neurodegeneration in the later life. Needless to mention how important are early years of life as well. It's very important to provide opportunities to these young children to be in school, to have life skills, to have school readiness, to have a non-abusive and safe environment, to have responsiveness by their caregivers. They should be allowed to play, they should be allowed to have healthy diet, they should be provided with opportunities for their growth monitoring, which should be monitored throughout. So all of these factors of early childhood development or that creates or impacts the brain architecture of these young children has a huge impact. There is a science of early childhood development that categorically mentions that these early 8 years of the human life sets the foundation of their later life outcomes, and these environmental factors have a great potential which has or and they can modulate normal functioning and physiology of human development. So these years and all of these factors are extremely important to track. These factors are extremely important to be made conducive in order to prevent the later life adverse outcomes of neurodegeneration. So the question comes that what can we do? It's very important to also regard early diagnosis in field of neurodegeneration. It's important to track the roots. It's important to go back to where we are coming from. So it's very important of all of us as practitioners to regard and respect early diagnosis or longitudinal tracking of developmental indicators from the intrauterine environment. Also, we need to practice bridging gaps in medical and socio-environmental health determinants, trying to weigh the fields of social sciences, medical sciences, environmental sciences as equal, as parallel, as integrated to support the betterment of human development. The fourth thing we can do is to prevention. Think of preventive health promotion strategies rather than waiting to cure something. Look at the environment, look at the climate changes and its impact bringing on human health and well-being, and avoiding all the possibilities of its adverse impact on the human development. And last but not the least, intrauterine environment and ECD should be considered as windows of opportunities to treat, to prevent, to monitor, to intervene, and to provide all the therapeutic interventions. These are the time we need to bring and focus all our interventions towards our origins, to the place or to the time which is igniting the first initiation of a life in this world, which is the intrauterine environment. focusing and bringing interventions from intrauterine environment and taking it to the life course approach. So these are few ways that we can actually contribute to the field of neurodegeneration by including all of these factors. And last but not the least, it's always going to be a journey for scientists, researchers, and practitioners. No matter how many determinants of health we throw in the mix, we will never be able to perfectly predict who will experience good health. However, the practice or the action towards or the call to action should not discontinue. The advocacy to provide the best health and well-being to our generations should be our target and should be our focus. With this, I would like to invite floor for any comments, questions, suggestions you may have. Thank you so much for attending this.
So thank you, Dr. Sadaf. Over to you.
Thank you, Dr. Shalina, for such an interesting and again yet interactive talk. Hopefully, students would like to ask some questions. If you have to ask some question, kindly write in the chat box. Dr. Shalina, I have a personal question. As there are certain reported factors, and we are actually looking forward to these type of researches as well, and it is some of the facts are being tested and reported that this is antenatal and this is prenatal and this is postnatal impacts. But are there any tested interventions that are recommended? Because we are recommending some lifestyle changes, some parenting changes, but are there other interventions that are reported with respect to the, you can say the techniques that I had talked about yesterday, about the music therapy, about the mindfulness, about yoga, about exercise, so such kind of interventions tested and to improve these qualities?
So Dr. Sadaf, it's a very valid thing. I would like to not, so first I would like to put a disclosure that the answer and the response is as per what I have studied so far. So I'm sure you might have also studied. The first thing that challenged the neurosciences field, I think whether it's early childhood field or the field of psychopathology that you're in, we face is that there is a very limited number of diagnostics and intervention, particularly focused towards neuro disorders. However, there are many interventions that we can work on. The first and foremost is genetic screening and genetic therapies that are being introduced, and this has very vital role to play in prenatal period. Then very streamlined, highly qualified, skill-based antenatal classes and education. Then starting the newborn caregiving therapeutic services on parenting, child rearing practices. Also, there is a huge part that policy of child protection plays in the neurodevelopmental sciences as well, because the abuse, the neglect, the physical, assaults that children face, it has a great impact on their later life outcomes. So all the therapeutic or preventive interventions are to do with education, and also there are some emerging facts pertinent to genetic therapies as well. But since I'm not the person of the genetic fields, I may not be able to talk about it. But yes, social science interventions are highly recommended, and which are fall under 5 categories of nurturing care framework by WHO that talks about intervention in health, nutrition, responsive caregiving, learning and simulation, and safety and protection. So these 5 components of nurturing care framework should be, or you can consider as a right of a child who is in the mother's womb and until the early years of life. So first 5 years are most significant to do these type of interventions. As far as genetic therapies and genetic counseling is included, our hospitals are doing those type of therapies and counseling and interventions as well. But since I don't belong to that field, so I cannot comment. But these are two levels of interventions, those can be done.
Okay, one more question from Shuja Heather is that autism and dyslexia are neurodevelopmental as we identify in early child. Then how it is play a helping in the future treatment?
So you see, it's very important if you have identified dyslexia, autism, or you can say some sort of like Down syndrome. In the early stages, the moment you have identified, it's the time you should do intervention. So you see, all these developmental disorders come from high level of genetic background. I'll give you my personal example. So my father was a severe muscular dystrophy person, okay? So there is a genetic pattern that follows. So every boy child, a female will be the carrier of that genes, and it will be transferred to every boy child. So I know this. I know this fact that I carry genes. Now I need to see what sort of environmental intervention will I or am I to make in order to avoid autism or avoid muscular dystrophy in my child. So there are several ways I could go about. A, I need to do a lot of genetic counseling. I need to do a lot of genetic screening before conceiving the baby. B, if I happen to conceive a baby and if I want to know that I know I'm informed that my baby will or have chances of having muscular dystrophy and Down syndrome or autism because it runs in my family, then I need to plan my interventions in accordance. I need to do screening, I need to do growth monitoring, I need to ensure that there is a inclusive education and opportunities provided to that child. And if that things are done, then later life outcomes, you will see a lot of Olympics champions who are Down syndrome children, autistic children are musicians. So you see, it all depends on the early intervention that we do. So we need, if you know, it's the best thing. It's very unfortunate in Pakistani population, 90% of people don't even know. So by the time, you know, it's identifies or it's sort of like diagnosed, it's too late already. But if you know at the prenatal stage, it's the ideal stage that you know about it. And that is how you can predict later life outcome. These children, all the autistic dyslexia children, dyslexia is a very minor learning disability. I don't even count dyslexia as kind of very high special need, but yes, autism is. So if you find and if you identified, kindly try to mainstream, kindly try to include these children into mainstreaming and social inclusive matter. And that is how you can do future treatments. And future treatment will definitely be advocacy, awareness, advocacy, advocacy, advocacy. People who have genetic background should know that what they will have once they will deliver their babies.
Dr. Shalina, one question is from Ayaz, that Ayaz is asking, is there any study of comparison of people with different genetic background living in the same environment? Like in USA, they have done such studies about people having neurodegeneration and something like that.
Like I mentioned, it's very unfortunate in LMICs, the neurodegenerative studies that are being done, they are retrospective, so there's no high clinical evidence that is established. Second, the ones which are there are very minimal longitudinal studies. So when you talk about neurodegenerative longitudinal study, you talk about a 25 to 50 year of cohorts. You don't talk about cohorts of like 5 months, 6 months, 2 years. So there is a limitation in the field, whether it's US or whether it's Pakistan or LMICs. In US, they have done a lot of studies whereby they have indicated how environmental factors impact neurodegeneration. Here in Pakistan, we do have studies, but the studies either are not scientifically robust or there are very limited scientific robust studies or recognized studies that can contribute into the field. So if you really type psychopathology, neurodevelopmental, you may also have some studies from Dr. Sadaf, but those are very limited. And here you may find little clinical studies which do not really justify as a national generalizable samples. So I think in the field of neurodevelopment, there is a high kind of agenda, or there is a high kind of opportunity available for the scientists and researchers to grow into that field. The other day, I was listening to a very good presentation by Dr. Sadaf's, one of the student. He was studying the aging indicators, and which was very new to me. because if you really put down things in PubMed, you will not find a lot of good cohort studies in Pakistan. So the number of studies are very limited. And hence, making a clinical claim is not justifiable with the kind of data we have in Pakistan. In US, yes, you can, but then the environment is very different. Like I just mentioned, there are very rare studies, but the models that I have showed you, there's a question by Joshua. Could you suggest any resources for further reading of early intervention for ND? I would suggest to in-depth study FIBAD, PAR, DOHAD models, and you will find a lot of interventions in those. Dr. Sadaf, over to you. Are there any more questions?
One more question we have. Could you suggest the resources for further reading for the early interventions for neurodevelopment disorders or neurodegenerative disorders?
So yes, Dr. Sadaf, like I just said, that there are very limited studies pertinent to intervention that start from the early age. If you're looking for the interventions that focus on the first 5 years, you should study the models that I spoke about, which is FIBA, DOHA, PAR, and LEARN. These are the 4 models. If you really study them in depth, you will have a pool of interventions that you can do in early years. Whereas later life studies in the palliative care, you will find a lot of interventions. But if you're looking for early interventions, these are the 4 models you should study in depth. Or Heckman's theory is one of the best models, I would say. DOHAD is the best model. So FIBA, DOHAD, life course approach of WHO, that is very nice as well.
Thank you so much, Dr. Shalina, for
models in chat box. Okay.
Informative talk. And Dr. Shuja, I think, is asking about some link.
So there are 4 models I have just listed in the chat log. It's FIBAD, DOHAD, PAR, and LEARN. FIBAD is fetal bias of adult disease. DOHAD is developmental origins of health and disease. PAR is predictive adaptive response, and LEARN is latent early life associated regulation. If you study all these 4 models in depth, because each model is a science in itself. So if you study them in depth, you will exactly know the early interventions, and also study WHO nurturing care framework. If Dr. Sadaf, someday maybe we can arrange a session on nurturing care framework, will be very helpful.
Yes, sure. Thank you so much, Dr. Shalina, for the time and for your expertise on this specific topic, because we had more the molecular and electrophysiological and the light on basically the molecular models and animal and human research. So we had discussed a lot throughout this program, but this was one of the very different dimensions that I always wanted to participant to know. And they must know that if they are even working for the mice models, and even they are working something related to the genetics and something, so they should know that where it has to be implemented and where the problem exists and what should be done. So thank you so much again. And we have covered this topic very, very, very interactively. So that's the most good part of the presentation. Thank you so much.
Thank you, Dr. Sadaf. And I would really like to acknowledge your efforts in making health inclusive. It used to be a medicine and biology and genetic sciences, but I have seen in all your programs, the social scientists, the scientists of nurturing care are always included in your program. And this is one of the great efforts in contributing to the public health, because when we talk about public health, it is inclusive. It is just not limited to medicine or biological sciences. So once again, thank you so much for always integrating social scientists in your program. It's one of the great efforts by AERC. Thank you so much. Take care of yourself. Everyone stay healthy, follow SOPs. Thank you so much. Bye-bye.
Thank you so much, everyone. Now we will be having our poster presentation session. We will be sharing the screen and announcing the title and the name of the presenter. We have with us Dr. Bilal Siddiqui, who will be chairing the session. Dr. Bilal Siddiqui is an MBBS, MSc in Public Health from United Kingdom. He is also a PhD scholar from Malaysia. He's doing his public health research. Dr. Bilal's specialty is maternal and child health epidemiologist, but as a foreign trained public health specialist as well. He is been in United Kingdom for the training, Malaysia and Kingdom of Saudi Arabia. He is one of the known public health specialists and academician teaching research, epidemiology, research methods, policies, social determinants of health, diseases, and health promotion. Dr. Bilal is with us to represent as his post as an academician and academic coordinator and director of ZABIS public health program. He is also associated with Canada-Pakistan Research and Development Council. He is founder of Child Health Registry of Pakistan, Center of Maternal and Child Health Research Division, and he is one of the known person who is the founder of many research projects and tools and techniques in Pakistan, associated with many reputed journals and research training programs. Thank you so much, Dr. Bilal, for joining us. We will be taking only 3 to 4 minutes break so that we can arrange the screen for the poster presenters, and then we will be able to get back to you. So start from the presentation. Thank you so much.
Thank you, Dr. Sadaf. Thank you so nice.
Okay, so Ujala, can you do the full screen? Yes. So we have the first presenter, Rida Nisar, who will be presenting a single electric shock induces considerable anxiety-like symptoms in rats, an animal model to screen putative anti-anxiety drugs. Rida, are you there?
I'm here, can you hear me?
Yes. Rida, you can start your presentation. You have 7 minutes.
Thank you, ma'am. Hi, I am Rida Nisar, and I am a junior research fellow at the International Center for Chemical and Biological Sciences, University of Karachi. The study I am presenting via my poster is part of my research work. And what we basically did here was to model anxiety on rodents, specifically by making use of an acute stressor to induce anxiety-like symptoms. Now, we use acute stressors because these acute stressors are what usually cause anxiety-like symptoms in normal life. However, in normal individuals, these acute stressors help us perform better and achieve our goals. So they kind of help us make work efficiently. But this scenario is completely different for a person that has neuropsychiatric disorder or an anxiety-linked neuropsychiatric disorder, as anything could serve as an acute stressor for them, and the problem worsens when these acute stressors start causing physical symptoms or appearance of physical symptoms. These physical symptoms can be things like hypothermia, tremors, palpitation, and shortness of breath. And the problem worsens even more once these physical symptoms start causing hindrance in performance of daily life functions. So it is imperative for us to keep looking for better treatment options for neuropsychiatric disorders or anxiety-linked neuropsychiatric disorders. And to do that, we need to model these diseases to screen anti-anxiety drugs, which brings us to our objective, which is to establish a technique that allows the modeling of anxiety or results in production of anxiety-like symptoms in experimental animals, and production of a relatively easier and effective way to model disease states seen in anxiety disorders. Now, to achieve this, what we did was to make use of electric shock as an acute stressor to cause induction of anxiety-like symptoms. And this electric shock was given to rat spots. To do this, to establish this as a model, we took 16 male Vistar albino rats and divided them into two groups, 8 rats per group, one control and the other was model group. Control rats were also placed on the same instrument that was used to give electric shock to the diseased rats. However, they didn't receive the electric shock. And the diseased rats received electric shock of intensity 1.0 milliampere and the pulse lasted for 1 second. Now, this intensity and the time for which the pulse lasted was decided beforehand through a pilot study that we conducted. And after induction of anxiety-like symptoms, we gave a resting period for all rats of 1 hour, after which we conducted behavioral analysis, including open field tests and light dark tests, and which was followed by decapitation to collect brain samples. And these samples were further then used to conduct biochemical analysis that included lipid peroxidation estimation by checking the levels of malondialdehyde, estimation of corticosterone, and reduced glutathione in brain samples of rats or both the control and disease rats. Now, the results that we got from this were kind of encouraging, and we saw in open field tests that freezing time, that is a marker of anxiogenic or anxiety-like behavior, was significantly increased in the model rats as compared to control, while the time spent in central circle that kind of indicates exploratory behavior or decreased anxiety was significantly decreased in disease model rats as compared to control rats. The results were reproduced in light dark test, as we saw that the time spent in light box, which is a marker of exploratory behavior or decreased anxiety or absence of anxiety, was significantly decreased in the model rats as compared to control rats. Biochemical analysis further strengthened our theory, as we saw that the levels of malondialdehyde, which is a marker of oxidative stress, which is usually increased in anxiety-like state, was significantly increased in the disease rats as compared to control rats. And corticosterone, the stress hormone, which is usually increased. Hello?
I am saying that your 3 minutes are left.
Okay, thank you. And the corticosterone, that is stress hormone, was significantly increased in the disease rats as compared to control rats, again showing anxiety-like behavior. And also for reduced glutathione, which is an antioxidant, was significantly decreased in the disease rats as compared to control rats, again indicating that oxidative stress was increased in the disease group or the group that is received electric shock. From this, we concluded that a single stressor of electric shock is able to induce anxiety-like symptoms in rodents, as we saw through behavioral testing and biochemical analysis. And thus, we can conclude that this animal model has potential to be used in preclinical studies to identify novel anti-anxiety drugs. We also plan to take this further and incorporate this in a proper study, in a bigger study that involves screening of anti-anxiety drugs and to see if there are any differences in electroencephalographic bands of rats that underwent anxiety induction through electric shock, and then compare it to those rats that did not get any shock. Lastly, I'd like to thank my supervisor, my mentor, who helped me through this study, Dr. Zahra Batul, and respectable Dr. Saida Haider, retired professor, University of Karachi, Department of Biochemistry. Thank you.
Thank you, Rida. Now, we will be having the question answer session at the end of the program. So if any of the participants have the question from Rida, they can note it down so we can have the question answer session at the end. And Dr. Bilal is also writing the comment. He will be commenting at the end of session. Now we have Deepak with us. Deepak will be presenting on antidepressant activity of morin hydrate. Over to you, Deepak.
Hello. Hello. Good morning. Good afternoon, everyone. Is it audible?
Deepak, your voice is not very much good quality. So if you can improve it.
Audible now, ma'am?
Yes.
Okay. Good afternoon, everyone. Myself, Dr. Deepak. And today here I am presenting my PhD work, antidepressant activity of morin hydrate in mice subjected to unpredictable mild stress. So, as we know, depression is a psychiatric disorder which is characterized by mainly symptoms like loss of interest, guilt, anhedonia, feeling of worthlessness, sleeping disorders. Means core symptoms are anhedonia and loss of interest, and after long time there will be induction of suicidal tendencies or suicidal thoughts. So here we selected morin hydrate, which is a flavonoid for the antidepressant activity. Already reported that morin shows anti-anxiety activity, nootropic activity, antioxidant activity, and also the neuroprotective. So here we employed the model for induction of stress is chronic unpredictable mild stress procedure. As we know, the stress is the major cause of depression. Due to stress, there was increase in elevation of oxidative stress, which caused neuronal toxicity, or we can say neuronal death, which further responsible for the depression. So here we involved only male mice for the study of weight 22 to 30 grams, and here we subjected mice to mild unchronic unpredictable mild stress. On first day, we immobilized the animal. On second day, we expose the animals to the foreign object. Third day, we use empty water bottle. Fourth day, overnight illumination. Fifth day, we can say tail pins for 30 seconds, and seventh day we use 60 seconds tail pinch. Means after that, after first week of exposure of these stress procedure, we repeat this procedure till 21 days. In our experimental protocol, we use two models. One is tail suspension test and second one is sucrose preference test. In tail suspension test, we involved two groups, stressed mice and unstressed mice. In stressed mice, we employed the stress and unstressed without any stress. After 21 days, we compared these stressed and unstressed mice with the help of tail suspension test and sucrose preference test. In tail suspension test in stress mice, after stress, there was significant decrease in immobility time period, but there was no increase in uh, immobility time period in unstressed mice. And other groups we involved Morin treated groups, means our drug treated group and standard drug treated groups fluoxetine. And the same groups we involved in sucrose preference test. We perform sucrose preference test because anhedonia is the core symptom of depression. So to check the anhedonia, we employed the sucrose preference test. The same group involved stressed and unstressed mice. 5 groups in stressed mice and 5 groups in unstressed mice. Okay. Now we are showing results. When we employed the stress, there was significant increase in immobility time period in tail suspension test, decrease in sucrose preference in stress mice, decrease significantly increase in corticosterone nitrite and MDA level, and significantly decrease in antioxidant and enzyme. When we provide treatment to these groups with our standard drug, fluoxetine, and our drug treatment, morin hydrate at dose 10 milligram, 20 and 40 milligram, there was significant elevation in significant elevation in oxidative parameters like catalase, significantly decrease in MDA level, nitrite level and corticosterone level. And majorly we check out the MAO activity also. We also check the MAO activity also. The morin hydrate significantly inhibit the MAO A enzyme. MAO enzyme responsible for the metabolism of our neurotransmitter like serotonin and noradrenaline. So here in conclusion, morin showed significant antidepressant-like activity in mice subjected to chronic unpredictable mild stress, probably through inhibition of brain MAO-A activity and decrease in plasma nitrate level and corticosterone level. And due to this and also affect the antioxidant activity. Thank you so much. Is it audible? Is it audible?
Yes, you are audible, Deepak.
Yes, sir. Ma'am, I completed my presentation. Completed my presentation, ma'am.
Ujala, can you change the presentation? Okay, thank you. Now we have with us Maha Shahid. Maha will be presenting on targeting altered TGF beta signaling pathway to halt phenothiazole induced epileptogenesis in mice. Maha, are you there?
Yes, I am there. Am I audible?
Yes, perfectly fine. Maha, over to you.
Okay. Thank you. Bismillahirrahmanirrahim. Assalamu alaikum. My name is Maha Shahid and I am enrolled as a PhD scholar in pharmacology from HEJ Research Institute of Chemistry, ICCBS, University of Karachi, Pakistan. And today I will be presenting the part from my research project, which is targeting altered TGF-beta signaling pathway to halt pantylene tetrazole-induced epileptogenesis in mice. So first of all, we will see what epilepsy is. Epilepsy is deliberated as one of the most common serious neurological disorder that affects around 1% of individuals globally. It is characterized by persistent disposition that generates seizures and associated with diverse etiology and symptoms. Regardless of many leading researches, still 1/3 of epileptic patients are not seizure-free and have to face serious side effects. Due to these unavoidable adverse effects, the introduction of natural treatment of seizures was carried out. advanced searches have now linked the various epileptic syndromes with inflammation. So for the exploration for better treatment strategies regarding epilepsy, the non-traditional pathway of TGF-beta, that is TGF-beta associated MAPK epilepsy, inflammation is increased. That activates the further downstream signaling pathway of TGF-beta. From that, TRAF6 is activated, and which phosphorylates then TAC1 gene. And this TAC1 then further activates the NF-kappa gene, JNKs, and P38. That again promotes the transcriptional factors and inflammatory cytokines, and this cycle continues. In the present study, the novel compound that I have used is isoxazolone, and whose potent anti-epileptic activity has already been reported, and it's a US patent compound and was provided by Dr. Ataur Rahman and his research team. So the objectives of this study was to evaluate the novel compound isoxazolone to terminate the epileptogenesis by targeting the TGF-beta associated genes in hope to discover the better treatment strategies regarding epilepsy. So to confirm the aforementioned evidences, we set up the kindling model of epilepsy, which is pentylene tetrazole induced, which is a convulsive compound. And for that, adult male biopsy mice were selected with their weight ranging between 18 to 25 gram and were divided into 5 groups, that is normal control group, pentylene tetrazole, and 2 standard drugs were taken, which is diazepam and valproic acid, and the last, which is our test compound group, which is easy isoxylotones. The test compound was administered daily with a dose of 30 milligrams per kg intraperitoneally, and same goes with the standard drugs diazepam and valproic acid. Except the normal control group, all the treated and untreated groups were administered with the subconvulsive dose of PTZ, which is 45 mg per kg intraperitoneally every alternate day, until the animals of the PTZ control group were fully kindled. That is, they showed the sequential score 5. Once they were fully kindled, the brain were harvested, followed by RNA isolation and cDNA synthesis and then amplification of the targeted genes for the mRNA expression. So our results, now moving on towards the results, in kindling study, the score was allotted to each rat according to the standard seizure pattern scale, and it was observed that the rats of the mice of the PTC control group significantly showed the score 1 on the first day of treatment, followed by score 2 and 3 with the second dose. And it was observed that the number that the seizure score significantly increases with an increase in the number of PTC injections. However, on the other side, if we see this, the treated group, which is isoxazolone, it significantly reduces the seizure generation, which is comparable to the diazepam group and valproic acid group. Next, for the mRNA expression of the TGF-beta associated genes, since we know that the TGF-beta, the genes of TGF-beta are associated with the with the growth, differentiation, and inflammatory reaction. So it is clearly seen here that the expression of TGF-beta is significantly elevated in the pentylene tetrazole group, and the test compound has reduced its expression. However, the expression was significantly reduced in the hippocampus as compared to the cortical region. Next, the TRAF6 gene, which is whose expression is also elevated in the PTC group, and the test compound has significantly lower its expression in cortical region. Next, the IL-1 beta, as we know that the expression of IL-1 beta, the expression in unaltered brain is hardly measurable. So it is clearly seen here, its expression is markedly elevated in tetrazole group, and our test compound along with the standard drugs have been the JNKs associated with the excitotoxin increased in PTZ group, and our test compound isoxazolone has significantly reduced its expression in both the region of interest, that is hippocampus and cortex. So in conclusion, we can say that isoxazolone is a potent anti-epileptic compound that protects from the convulsive effects of pentylene tetrazole, and TGF-beta signaling pathway can serve as a potential subcellular target for reducing seizure generation and associated neuronal death in epilepsy, and isoxazolone is an effective way to achieve this therapeutic target. Thank you. That's all from my side, and I want to thank my supervisor and my co-authors and Dr. Ataur Rahman and his research team for providing me with the compound. Thank you.
Thank you, Maha. Now we have Rushda Afroz. She will be presenting on injected metformin reduce acute stress effects on behavior. Rushda, are you there?
Yes, I'm here. Thank you
Yes.
so much. I'm Rushda Afroz, doing my PhD under the supervision of Dr. Draksha Halim. Basically, this study was performed to evaluate the effect of metformin treatment on behavior and hippocampal monoamine metabolism of rats exposed to 2-hour restraint stress. Let me give you some information about the metformin. It is an FDA-approved drug and most widely used insulin sensitizer. It can cross blood-brain barrier to facilitate hippocampal neurogenesis. Currently, metformin is most recommended anti-diabetic drug. Its low cost make it a remarkable choice for the policymaker, researchers, physicians, and the patients. Coming towards the stress is known to produce many physiological and behavioral changes. Previously, studies has been done that showed acute exposure to uncontrollable stress, that is 2 hours immobilization stress, produce marked anorexia, and animal exhibit anxiety-like effect. As metformin can cross blood-brain barrier, so we suggest that it could be used for the treatment of stress-related disorders. Coming towards the methodology, for this experiment, we used 24 male albino star rats and divide equally into 4 groups: saline unstressed, metformin unstressed, saline stress, and metformin stress. We administer the drug intraperitoneally, and after 30 minutes of drug administration, we expose group 3 and group 4 rats to restraining tube. Then next day, after 24 hours, we monitor the body weight. After that, drug was administered and the rats were placed back in respective home cages. After 40 minutes of drug administration, we monitor open field activity for the period of 5 minutes, and elevated plasmase activity was monitored for the period of 5 minutes after 1 hour of drug administration. Then rats of group 3 and group 4 were placed in the restraining tube for 2 hours. And after removing rats from the restraining tube, we decapitate the rats and isolate hippocampus for determination of monoamine and their metabolite in the hippocampus. Coming towards the results, the present study showed that metformin treatment to stress animal decreased body weight. And about the activity in the elevated plasmase, you can see that stress exposure decreased time spent and number of increase in open arm in saline injected rats, but conversely, metformin treatment to stress and unstressed rat significantly increased time spent and number of open arms, suggesting anxiolytic effect. Data of activity in open field environments show that stress exposure decreased activity in the open field, but metformin treatment to stressed and unstressed rat increase activity in the open field environment. Now, about DOPAC and the dopamine, that is, DOPAC is the metabolite of dopamine. We found that stress exposure decreased the level of DOPAC, but metformin treatment to stress and unstressed rats exhibit greater level of dopamine and its metabolite. Noradrenaline level were also found to be decreased by the stress exposure in the saline injected rats, but as compared to saline treated stress animal, these level were found to be increased in metformin treated stress and unstressed rat. The level of 5-HIAA and 5-HT was found to be decreased in saline-treated stress animal, but this effects was found to be increased in metformin-treated stressed and unstressed animal. So from this study, we can conclude that metformin reduce acute stress effects on anxiety by increasing monoamine neurotransmission in the hippocampus. This is all from my presentation. Thank you.
Thank you, Rushda. Now we have Asiya Afzal. She will be presenting on therapeutic potential of curcumin in reversing the depression. Asiya, are you there?
Yes, I am there.
Yes, over to you.
Hello everyone, I am Asiya Afzal from Department of Biochemistry, University of Karachi. Recently, I have completed my PhD. The topic of my presentation is therapeutic potential of curcumin in reversing the depression and associated memory impairment via modulating hippocampal neurotransmitters in male rats. I focus on pseudodementia in my study. What is pseudodementia? Pseudodementia is the memory deficit secondary to depressive disorder are called pseudodementia. Pseudodementia seems to be like dementia, but it is different from dementia. It can be reversed, and the memory deficits found in depression are considerably less as compared to true dementia. So there is a need to differentiate the pseudodementia from true dementia, not only for the treatment, but to avoid unnecessary evaluation. If this condition remain untreated, it may progress towards the dementia. The purpose of study was to investigate the symptoms of pseudodementia in animal model of depression and to find out the possible role of curcumin to reverse depression-associated pseudodementia. Material and methods of the study was that 24 albino Lister rats were taken and they were divided into 4 groups: control, depression, depression plus curcumin, and curcumin. Depression was induced by 14 days of chronic restrained stress for 4 hours daily. After inducing depressive symptoms, behavioral tests, including pattern separation test and Morris-Water-Maze test, were conducted to screen the pseudodementia. After behavioral tests, rats were treated with curcumin at a dose of 200 mg per kg and for a week orally, and after treatment with curcumin, rats were subjected to above described behavioral test, which is force swim test, Morris-Water-Maze test, and pattern separation test before decapitation. After decapitation, hippocampal tissue were analyzed for the neurotransmitters 5-HT and dopamine levels. These are the apparatus used in my study. First one is a force swim test for the evaluation of depressive symptoms, and second one is a pattern separation test, which was specially designed for my study, and third one is Morris-Water-Maze test, and these are the restraint stress tubes for chronic restraint stress, and this is the HPLC apparatus for the evaluation of 5-HT and dopamine levels. These are the results of my study. First graph shows a force swim test in which before curcumin treatment, both the depressive group have increased immobility time as compared to control. And after curcumin treatment, depressive group have increased immobility time as compared to control. And the yellow one bar, which is curcumin plus depression group, have reduced immobility time as compared to depression group, which shows the antidepressant effects of the drug. Second graph is PST-SNO, which is pattern separation test for similar new object, in which before curcumin treatment, both the depressive group have reduced discrimination index or ability as compared to control rats. And after curcumin treatment, depression plus curcumin group have increased discrimination ability as compared to depressive group. And alone curcumin group also shows increase in discrimination ability as compared to normal control rats. And this is the result of Morris-Water-Maze test. Before curcumin treatment, both the depressive group have reduced time spent in target quadrant as compared to control, which shows impairment in memory. But after curcumin treatment, depression plus curcumin group have increased time spent in target quadrant, which shows the normal memory processes as compared to depressive group. And this is the result of 5-HT levels this is the result of 5-HT. Okay. These are the result of 5-HT levels. Depression plus curcumin group have increased 5-HT levels as compared to the depressive group. And the fifth graph is of dopamine levels. Dopamine levels were evaluated, and depression plus curcumin group showed increased dopamine levels as compared to depressive group. And finally, I can conclude that pseudodementia can be reversed by controlling the factors which are involved for the onset of pseudodementia. And curcumin is a useful compound which can ameliorate depressive symptoms and associate memory disturbances. And curcumin regulate neurotransmitters and it reduce memory disturbances. There is a lot of work has been done on curcumin, but I focus on pseudodementia. And still there is a need to work more on curcumin related to pseudodementia. And finally, I want to say thanks to my supervisor, Dr. Saida Haider, and my co-supervisor, Dr. Zahra Batul, and all the members of my research lab, NBN unit. And thank you very much for listening me.
Thank you, Asia. We will be taking the comments at the end of the session. Now we have with us Sumbul Zahra. She will be talking on exploring the role of cardenolite in glioblastoma, U87 cells. Sumbul, are you there?
Yes, I'm here. Hello. Hello, everyone.
Yes.
My name is Sumbul Zahra.
Yes.
I'm a PhD student. Can I start? Okay. Am I audible to everyone? Hello?
Yes.
Okay, I'm starting. My name is Sumbul Zahra. I'm a PhD student at Dr. Panjwani Center for Molecular Medicine and Drug Research, International Center for Chemical and Biological Sciences, University of Karachi, under the supervision of Dr. Shabana Usman Simji. The topic of my poster presentation is exploring the role of cardenolites in glioblastoma U87 cells. Glioblastoma is a primary brain tumor that is highly invasive and aggressive in nature. Right after the diagnosis is made, the patient survival is only about 12 to 15 months. As the treatment for glioblastoma is a challenging task, so it is utmost important to develop new drugs having potential to treat glioblastoma. Here in this study, we conducted the anti-cancer activity of two cardenolites, gitotoxygenin and DG-toxygenin, against glioblastoma U87 cells and compared with the standard drug temozolomide, for which MTT assay was performed and IC50 values were calculated for 24 hours. The IC50 values of Gito, DG, and temozolomide were found to be 17 micromolar, 2 micromolar, and 1000 micromolar respectively. Later on, real-time PCR was performed for gene expression analysis and immunocytochemistry was done to check protein expression. Talking about the gene expression of BAX, BCL, and caspase-3. As it is clearly seen from the graph that Gito and temozolomide significantly increased BAX and BCL ratio, making their role in apoptosis, while DG could not significantly increase BAX and BCL ratio. Let's come to the caspase-3 gene expression. It is clearly shown in the graph that all of the treatment groups significantly increased caspase-3 gene expression, with the fact that DG produced the highest increase in the caspase-3 gene expression, making its role in apoptosis through caspase-3 activation. The results of caspase-3 gene expression also consistent with the caspase-3 protein expression. Here are some images shown of caspase-3 protein expression of control and treatment groups, Gito, DG, and temozolomide. It is clearly shown from these pictures that the caspase-3 protein expression is increased in the treatment groups when compared to the caspase-3 protein expression in the control group. It is also seen from the caspase-3 protein expression graph that all of the treatment group increased the caspase-3 protein expression. If we compare the caspase-3 protein expression with the caspase-3 gene expression, then we come to know that Gito significantly increased the caspase-3 gene expression, but it could not significantly increase the caspase-3 protein expression. Explaining that caspase-3 gene was more produced by Gito, but it could not synthesize more caspase-3 protein. So while temozolomide and DG significantly increased the caspase-3 gene expression as well as caspase-3 protein expression. So here I conclude all the results with the fact that G2 and DG inhibit the growth of glioblastoma U87 cells. Hence, both possess anti-cancer activity. Future perspectives include cell cycle analysis, apoptosis analysis, and immunocytochemistry. In the end, I want to thank my supervisor and my co-authors. Thank you. Hopefully the description was well defined. Hello.
Sumbul, sorry, actually we got disconnected. I'm again sharing the screen, and you can then continue with your conclusion.
Okay. So in the end, I conclude that G2 and DG possess anti-cancer activity as they inhibit the growth of glioblastoma U87 cells. The future perspectives include cell cycle analysis, apoptosis analysis through flow cytometry, and immunocytochemistry. So in the end, I would like to thank my supervisor, Dr. Shabana Osman Sinji, and co-authors. Thank you. And hopefully the description was well defined.
Thank you, Sumbul. And we will be taking all the question and comment in the end of the session. And now we move on to our next poster. That is by Mariam Ijaz. She will be presenting on microemulsion based synthesis. Mariam, are you there?
Yes, I am there.
Yes, Mariam, you can now continue.
Assalamu alaikum. My name is Mariam Ijaz. I have done my MPhil from Bahauddin Zakriya University, Multan. My topic is microemulsion based synthesis of strontium hexaferrite.
Mariam, you are mute.
Okay.
Yes.
Microemulsion based synthesis of strontium hexaferrite, cobalt, iron oxide nanoparticles and their biocompatibility in albino mice. A number of strontium-based iron oxides are available for the industrial use. Among them, strontium hexaferrite cobalt iron oxide is preferred over others due to its better magnetic and electrical properties than others. This material is also extensively used for the absorption of microwave radiations. This study was conducted to account for the synthesis of the characterization of strontium cobalt iron oxide nanoparticles and to report their biocompatibility in albino mice. Nanoparticles were synthesized by normal microemulsion. XRD analysis confirmed the single and scanning electron microscopy revealed average particle size range between 30 and 50 nanometer. 9-week-old male mice were intraperitoneally administered with 50 milligram per microliter of solvent per kg body weight of the strontium hexaferrite cobalt iron oxide nanoparticles for 22 days. Control group were maintained in parallel. A series of neurological tests, Rotarod, light and dark box, open field, and Morris water maze were conducted in both groups. Blood samples were collected from direct cardiac puncture and parameters of complete blood count, serum biochemical parameters, and antioxidants were determined in liver and brain tissues of all subjects. Analysis of result revealed that all studied neurological test performance varied non-significantly between the two treatments except clockwise rotation during open field test that were significantly varied in strontium hexaferrite cobalt iron oxide nanoparticles treated male albino mice than in the control group. All studied complete blood count and serum parameters varied non-significantly between two treatments. It was observed that superoxide dimutase concentration was significantly higher in the liver of the nanoparticle treated male mice. In conclusion, we are reporting that applied dose of strontium hexaferrite cobalt iron oxide nanoparticle is affecting the exploratory behavior and antioxidant metabolites of male albino mice. Our result indicated that 50 milligram per milliliter solvent per body weight of strontium hexaferrite cobalt iron oxide nanoparticles didn't affect the studied neurological, hematological, and serological parameters of albino mice of both genders when compared with saline-treated control mice. Analysis of antioxidant metabolites in liver has indicated that the applied dose of strontium hexaferrite cobalt iron oxide can disturb the hydrogen peroxide associated metabolic pathways that result in increased SOD concentration in male mice. That's all about my presentation. In the last, I will thank Dr. Farhan Iqbal that supervised my presentation and my research work. Thank you.
Thank you, Mariam. Now our next presenter is Shazia Nawaz. She will be presenting on inhibition of methyl phenidate inducing reinforcing effect and improvement of memory. Shazia, are you there?
Assalamu alaikum.
Walaikum assalam. Thank you. Over to you.
I'm Shazia Nawaz from DCMD. The topic of my presentation is inhibition of methylphenidate induced reinforcing effect and improvement of memory by serotonergic compound. MPD is used for ADHD, but it is a psychostimulant, but it produces abuse potential in patients which are treated with methylphenidate. It is also misused by college students to improve their memory during examination. The present study was designed to see the abuse potential of MPD at clinical dose and inhibition of its reinforcing effect. From previous study, 5-HT1A receptor has role in cognition and addiction. So we choose serotonergic compound to inhibit the methylphenidate induced reinforcing effect. We also buspirone is one of the serotonergic compound which previously inhibit morphine and apomorphine induced addiction. So we selected buspirone, and another drug which is myanserin. It is also act on serotonergic receptor. It is antagonist at 5-HT2A and 2C receptor. From clinical study, it has shown to produce in Parkinson disease patient. It inhibits psychosis as well as in schizophrenic patient. It improved memory. So myanserin was selected because 5-HT1A receptor has role in memory and addiction. So we designed this study to study the role of these two drugs on methylphenidate-induced addiction. 36 rats were selected for this study, and we divided into 6 groups. To first group, we administered saline and water. Then second group was administered with buspirone, 0.1 milligram dose, and myanserin was at 5 milligram was administered to rats, and another group of methylphenidate drug which was used at dose of 2.5 milligram. Then buspirone and MPD co-administered group, and myanserin and MPD co-administered group. Addiction was evaluated by CPB paradigm. CPB paradigm, this is consists of 3 phases. In first phase, rats were not administered with any drug and explored the apparatus for 10 minutes. Then conditioning phase was started from next day to for 12 days. On alternate day, we administer drug and confined to it to drug compartment, and other days it was administered with saline or water. and confined to another compartment, which we associated with non-drug compartment. After 12 days, on day 13, false conditioning test was conducted, and we see the time spent in drug compartment to see if addiction is produced or not.
3 minutes left.
From our result, it is shown that methylphenidate produce preference in the compartment, that is addiction, which was inhibited by 0.1 milligram buspirone as well as mycin 5 milligram dose. The memory result, the methylphenidate improve memory, and the both doses, when administered alone or co-administered, these improve memory. Memory was also improved by buspirone 0.1 milligram and 5 milligram dose of mycin. So these two drugs inhibiting addiction effect without affecting the memory. So we conclude that these two drugs can be co-administered with MPD to block the addictive effect of MPD um, without affecting its memory effects, and this can improve ADHD treatment and other cognitive deficits and addiction. Thank you.
Shazia. Our next
Yes.
Our next presenter is Kinza Rafi. She will be presenting on role of quinine acid and its derivative in inhibiting Alzheimer's disease. Kinza, are you there?
Yes, I am.
Yes,
Yes,
you
I
can
am here.
start your presentation.
My name is Kinza Rafi, and I have recently completed my PhD in molecular medicine from Dr. Panjwani Center for Molecular Medicine and Drug Research, University of Karachi. Here, I am presenting part of my PhD research entitled Role of Quinic Acid and its Derivatives in Inhibiting Alzheimer's Disease-Associated Neuroinflammation in SHSY55 cells. Neuroinflammation plays an important role in the pathogenesis and progression of Alzheimer's disease. The production of inflammatory mediators and oxidative stress causes synaptic dysfunction that is responsible for Alzheimer's associated memory decline. So to understand the role of inflammation in Alzheimer's disease pathogenesis, we have developed an in vitro model of AD using the mitogen phytoheme agglutinin with an aim to target Alzheimer's at early stage by suppressing neuroinflammation and to delay the onset and progression of Alzheimer's. We begin our study to observe plaques formation using phytoheme agglutinin that releases cytokines upon stimulation. The cells were initially incubated with PHA at various concentrations for 24 hours. After incubation, cells were observed using phase contrast microscopy. Then oxidative stress was analyzed at different concentrations of PHA by fluorimetric method using the dye H2DCFDA. Further, the disease model was confirmed and validated by RT-PCR and immunocytochemistry. After confirming the role of PHA in neuroinflammation and ROS production, neuroprotective effect of quinic acid and its derivatives was evaluated against plaques and tangles formation. Moving to the results, we have found that most of the plaques formation using PHA was at 10 microgram per ml. Then oxidative stress analysis demonstrated maximum ROS production at 10 microgram per ml of PHA. Gene expression and immunocytochemistry analysis at 10 microgram per ml of PHA showed increased expression of inflammatory and Alzheimer's disease associated pathological markers. Then we screen quinic acid and its derivatives for the proliferative potential through MTT assay and found that the tested compounds were increasing the cell viability. Moving to ROS production, we have found that the compounds reduced PHA-induced ROS in SHSY55 cells. Moreover, from the results of PCR, it was observed that the compounds reduce the mRNA expression of inflammatory markers such as IL-1 beta, TNF alpha, and the MAPK P38 isoforms P38 alpha and P38 beta. From PCR, we have also found that none of the compound elevated the mRNA expression of ADAM10 gene, and also none of the compound is responsible to reduce base one, that is beta secretive gene expression. Then further exploration of the mechanism of these compounds through immunocytochemistry showed that the compounds reduce the protein levels of amyloid beta plaques, hyperphosphorylated tau, as well as the activated P38 MAP kinase that is responsible for tau protein hyperphosphorylation. Thus, from the observations, it was concluded that PHA possesses role in the development of Alzheimer's disease pathology, and the compounds tested in this study have the potential to reduce the disease pathology by suppressing neuroinflammation. And thank you.
Kinza, there is some problem with your. Thank you so much, Kinza, and sorry for the interruption. Now we have Hira Rafi. She will be presenting on inhibition of NMDA receptors. Hira, are you there? Hira. I guess we don't have her with him. We will continue to our next.
Hello. Yes.
Yes. Hira, are you there?
Yes.
Yes, you can continue.
Okay, thank you. My name is Rafi, and I'm a student at Department of Biochemistry, University of Karachi. And what I'm presenting today is inhibition of NMDA receptor by agmatine treatment that mediates the UCMS-induced GABA glutamate dysregulation. Agmatine is a polyamine produced during arginine metabolism. Recently, it has been considered as potential neurotransmitter or neuromodulator. It has been evolving as potential therapeutic for depression and many other psychopathologies. So currently, researchers are more attentive towards GABA and glutamate homeostasis for the treatment of depression. And in this study, we have targeted NMDA receptors for inhibiting glutamate excitotoxicity and increasing GABA activity by chronic treatment of agmatine. For this, we have taken animals into two groups, unstressed and UCMS treated group. UCMS is unpredictable chronic mild stress. And in this paradigm, we have 28 days treatment for different stressor with animals. And the animals were divided into two groups, unstressed and UCMS group, which were further divided into three groups, water, agmatine, and mirtazapine. Mirtazapine has been taken as positive control for comparing the results of agmatine. So results had shown comparable results of agmatine with conventional drugs in 4 swim test, elevated plus maze test, and open field test. These results have shown improved locomotion and antidepressant activity of stressed animal. The other results have shown similar results that were increased level of GABA. However, glutamate level were comparable decreased in agmatine group in stressed animals. And moreover, corticosteroid level was also decreased in agmatine treated animal. So in conclusion, we have concluded that this study has revealed significant enhanced locomotor activity, and behavioral despair was also decreased in animal treated with agmatine. This study has also determined significant increase in GABA level, however, decrease in glutamate concentration in agmatine treated stressed animals. Agmatine has also reduced concentration of corticosterone in stressed animals. So what results have been obtained has suggested that agmatine as a potential candidate for the treatment of chronic stress and anxiety by regulating GABA glutamate homeostasis. Thank you.
Thank you, Hira. Now we are moving to our next poster. It is Atir Rajput, and he will be presenting cognitive decline among elderly individuals suffering from diabetes mellitus. Atir, are you there? I guess we do not have Atir with us. We will move to our second poster. Uh, Our next presenter is Meena Gupta. She will present on cognitive enhancement in neurodevelopmental delay children employing repetitive transcranial magnetic stimulation. Meena, are you there? Meena. I guess we should move to our next poster. She is also not with us. Our next poster presenter is Yusra Sareem. She will be presenting on evaluating age-related cognitive performance, a pilot study from Pakistan. Yusra, over to you.
Okay. Hello everyone. My topic for presentation today is evaluating age-related cognitive performance. This was a pilot study from Pakistan. Am I audible and is my screen there? Okay, let me just start. When we begin with cognitive performance and cognitive impairment, cognition is critical for functioning independence as people age, including whether someone can live independently, manage finances, take medications correctly, drive safely. In addition, intact cognition is vital for humans to communicate effectively. As you can see in the graph on the left side of your screen, that with the age progressing towards 90, the cognitive impairment starts and normal aging starts, and then after that the mild cognitive impairment you can see, and then abnormal aging, that is towards a neurodegenerative disorder, that will be the severe cognitive impairment, and that is with the progression of age. Cognitive abilities often decline with age. It is important to understand what type of changes in cognition are expected as a part of normal aging. So we need to differentiate what is a part of normal aging and what is a symptom or signs of neurodegenerative disorder, that is abnormal aging. We conducted a cross-sectional study over a sample of 200 subjects, including both male and females, and we divided them into three groups, that is younger adults and middle-aged and older adults. For cognitive assessments, MMSE and mini cog were used with predetermined cutoff values. A point was scored for each correct answer based on the participant familiarization. We collected the data and it was assessed, analyzed through SPSS version 22. These can be seen as common signs of mild cognitive impairment. Decision making is affected, and then abstract thinking is affected, and neglect of hygiene, and then impulsive behavior can be seen. So the results of the study were severe cognitive impairment was seen in 5 of these study participants. Mild was more prominent, that is among 46 participants, and no cognitive impairment was seen in 149 participants according to MMSE score, and similar results were found using the mini-cog score. This can be seen in the graphs as well. The figure 1 and figure 2 shows age-associated decline in MMSE score and mini-cog score. You can see the mean values here, 26.38 mean was seen among youngers, and then olders it is like 24.06. So the conclusion of this pilot study was the cognitive performance in different age groups yielded positive outcomes. Both MMSE and mini-cog findings were comparable and indicated that there was significant age-related cognitive decline, which were comparatively more pronounced among males and females both. Jala, thank you so much. And I would like to thank Huma Bhakti and Dr. Sada for her assistance during the study.
Now we will be moving on to our previous poster. I guess there was some connectivity issue in Meena Gupta. Now, Meena, are you there?
Yes, ma'am, I'm here. Am I audible?
Yes. Yes, you are audible. Your time starts now.
Okay, so very good afternoon, all of you. I'm Dr. Meena Gupta from India. I'm working as assistant professor in MIT Institute of Physiotherapy, Noida. So the topic of my study is basically related to the human beings. So in this study, I have completed or I'm doing cognitive enhancement in neurodevelopmental delay children employing repetitive transcranial magnetic stimulation. So I'm just want to give brief presentation about the what is the cerebral palsy. It is one of the non-progressive neuromuscular developmental delay which is seen in the pediatric population. As a physiotherapist, I know how to deal with the patient for a milestone delay. But if we talk about the cognitive aspect, there is a very lesser therapies are available to improve their cognitive enhancement. So in this study, I have employed many biomedical engineering instrumentation, for example, repetitive transcranial magnetic stimulation, neurofeedback, and the cognitive exercises. So the objective of the study was to identify which one is best therapeutic modality to improve the cognitive impairment or enhance the cognitive cognition in the pediatric population who have a developmental delay or due to the brain insult. So in this study, what is the method I have approached? The study design was experimental, pre versus post test control group, and the data was collected from the Lajpat Nagar. It is situated in Delhi. And tool which I have used is mentioned here: physical assessment performer, gross motor function classification system, Van Line social maturity scale. It is the psychological scale. On the basis of that, we can identify the present level of the cognition, and after the intervention, we will see what kind of the changes can be seen in the patient. And after that, we have collected the raw EEG data, electroencephalography with the qualitative manner. Now, inclusion of the criteria: age group 5 to 18 years. Both the genders were included, male and female, to avoid the bias. Willing to undergo the therapy, seizures under control medication, diagnosis with the spastic and mixed cerebral palsy, mild to moderate mental retardation, ability to cooperate and follow instructions, and gross motor function classification system for the CP. Now, exclusion criteria, as mentioned here: any metallic implant, and age below than 5 years and more than 18 years, any developmental of unstable medical condition or severe behavioral disturbance, and refusal of the therapy. So in this methodology, we have divided the patient in three groups. One is the control group. In another, there is this experimental group. In experimental group, we have further divided the patient into three groups. One for the RTMS therapy, second group for the neurofeedback therapy, and third one is for the cognitive exercises. So in the repetitive transcranial magnetic stimulation, we have given 20 sessions in a month, 5 sessions per week for half an hour on the temporofrontocortical of the brain to stimulate the deep brain stimulation. In neurofeedback therapy, we have given the theta waves to stimulate the brain for half an hour. Similarly, for 30 days, means 1 month therapy for half an hour. And in last group, that is cognitive exercises, we have introduced half an hour exercises, which is related to the recreational activity, bilateral hand coordination, and dual task type of the activity. Now, after the interpretation of the result, we have uses the SPSS and MATLAB mathematical tool to analyze the data. So it suggested that in group A, that was our control group, it is showing VSMS having 0.85% changes in the cognition. In group B, that is our repetitive transmagnetic stimulation group, it having 1.28% changes. And in group C, that is our neurofeedback group, it having 0.98% improvement. And in group D, that is our cognitive group, it having 1.17% changes. So similarly, for the different waves of the brain that present the cognition, alpha waves, theta waves, and beta waves, we have calculated all the parameter in the same groups. So what we have find out that the group B and group D. So group B is the RTMS group and group D is the cognitive group is showing best result. In the graph, as I have mentioned here, in the graph, the maximum mean shift change of the theta peak frequency is seen again in the group B and D, and it suggested the improvement in the cognitive domain and the neuroplasticity. So as you all are able to see the diagram, how we are providing the treatment to the help of the RTMS on the scalp of the patient. Okay. Now, what we concluded, the proposed null hypotheses are rejected on the basis of the study result, and thus we say that RTMS therapy and neurofeedback and cognitive exercises are effective non-pharmacological management therapy for CP patient who having mild and moderate mental retardation. And this study employs RTMS, neurofeedback, and cognitive therapies provides to be effective in the improvement in cognitive functioning and physical performance of the cerebral palsy. Out of all intervention, RTMS was found to be a most effective therapy as compared with the other therapies. So it shows 1.28% improvement in VSMS, that is Vineland Social Maturity Scale, and it is a psychological tool, and 1.63 oblique 4.33% change in the peak shift in the alpha and alpha theta waves, representing effective therapy. Now, cognitive exercise is the second most effective therapy for cognitive enhancement in CP patient with mild to moderate mental retardation, and it's showing 1.17% improvement in VSMS score and 1.17 oblique 3.84% peak shift in their amplitude in the alpha theta waves respectively after the therapy. So we have concluded RTMS is the best therapy for improving the cognitive enhancement in the cerebral palsy patient because these patients having poor understanding. So that's why we are not able to get more result in the physical domain. So if we improve the cognition, we can improve the physical milestone also. So that's all about my study.
Thank you, Meena. Moving on to our next presenter. Our next presenter is Faizan Mirza. He will be presenting on non-invasive indicator of neurological decline. Faizan Mirza, over to you.
Okay, hello everyone, this is Faizan Mirza. The study that we conducted was basically for non-invasive indicators of neurological decline. This study was conducted in population of Karachi. The background of this study was that we were trying to figure out what factors can we look for in apparently healthy individuals to see neurological decline. And the subject that we selected in our study, we stratified them on the basis of age categories into 3 age brackets and 4 socioeconomic classes. The objective of our study was to just make sure that the neurological decline which is occurring in apparently healthy individuals is highlighted, so we can target the vulnerable population or the niche group, and interventions can then be suggested to them for a better lifestyle. So what parameters we measured? We took 412 subjects in this cross-sectional study. Hand grip strength was measured using a hand dynamometer. Olfactory performance was assessed using the sniffing sticks imported from Germany. Verbal fluency and associative learning were assessed using FAS test and DSST respectively. The results were analyzed using SPSS 22.0 and P less than 0.5 was considered significant. Our results were a bit alarming for us because when we took apparently healthy individuals, we expected them to have a good hand grip strength, majority to be having a good hand grip strength. But we found that yes, the hand grip strength declined from 23.3 kg to 17.1 kg and was weak in majority of participants. Out of 412, 279 of our participants were having a weak grip strength, and although apparently they were all healthy. Olfactory performance again is something that we found out that our population or individuals who are apparently healthy, they were over confident that probably their sniffing ability or olfactory performance is good enough, whereas it was not. So majority of our participants again in this case were hyposomniac, and 324 out of 412 were hyposomniac. That was a big alarming thing for us to see that these are apparently healthy individuals suffering from some kind of decline in their motor skills or olfactory pathway, and which is going unnoticed or unscreened. Time for performing associative learning tasks was significantly increasing as aging went on. Verbal fluency score was greatly decreased due to aging in the 3 age brackets. When we considered all these variables and we compared them with obesity and correlated with socioeconomic status, we found that there were significant correlations. We found some unique outcomes in this study. Upper middle socioeconomic strata individuals in the age group of 20 to 36, they are expected to be among the ones who have a very good, you can say, turnover of material benefits in life, but still their hand grip strength was poor. Now, poor hand grip strength is related with early mortality. All the researchers, they suggest that a poor hand grip strength, it is a it's a sign, or you can say it's an alarm for an early mortality. And every and a better grip strength means a better and a longer life, and much longevity in that individual. Middle socioeconomic status, as well as, and we found that the upper middle socioeconomic status had poor olfactory performance as well. The middle socioeconomic status in 20 to 36 individuals, they had again the weak grip hand grip strength. Individuals of the lower socioeconomic classes had the weak most hand grip strength in all the three age brackets and all the four socioeconomic status. So the idea of this study was to use these screening tools and to make the population aware that if these are included in routine screening, then we can predict the likelihood of the vulnerable population, all individuals who are vulnerable in our population, and then they can be subjected to different interventions before their degeneration, or you can say diseases have started. Because right now the decline is just initial, it has just started, it has not yet turned into a certain disorder. But if this decline is going unnoticed, these individuals who are in the age group of 20 to 36 will go on to 37 and 56, and they will become they will undergo accelerated aging. Their decline will be more pronounced, and the features of that decline will be very visible. And among the studies that we were going through, we found out that low socioeconomic status in the childhood is related with a poor olfactory performance in the adult life. Another feature we found out in some studies was that the stress level in the life of an individual due to occupation, which means what job you are doing, it also pushes you to have a weaker grip strength and a poor olfactory performance as well. And this all shows a kind of neurological decline which is occurring way early in life, whereas these kind of neurological decline are hallmarks of an old age population. The conclusion I have just summed up together with my discussion, that the population who can be targeted using these screening tools can then be helped out, because it is not people who think that they are apparently healthy. It turned out that their olfactory performance or their hand grip strength or their verbal fluency or the associative learning tasks are suffering, and this is indicating a neurological decline. That's it from my side. Thank you so much.
Okay, sir. Moving to our next poster presentation. Our next poster is from me. Hi everyone, it is Ujala Sajid from University of Karachi. My topic for today's presentation is assessment of physiological biomarker detecting cognitive decline and neurodegeneration after trauma. Okay, there have been a study that have found that multiple neurobiological mechanisms are underlying the cause of post-traumatic stress that influence the nervous and immune system, leading to neurodegenerative and psychiatric diseases or comorbidities. Our present study aims to assess and evaluate the serum cortisol, CRP, interleukin 6, BDNF level, and cognitive decline among subjects with trauma exposure, and to determine the relationship between the specified stress biomarker. What we do that we form two groups with trauma exposure in the last 12 months, and they were recruited on the basis of TSC 40 score, trauma stress score. Traumatized group include all the subject with a TSC score above than 40, while the control group include all the subject having a scoring less than 40. Our sample size include 188 subjects above the age of 18 and were recruited from the inclusion criteria of our study. While the cognition level of individual were measured using the 6-item cognitive impairment test. And for determining the cortisol, CRP, BDNF, and interleukin 6 level, we conduct the serum test and we collect their blood. Our results show that there was a significant difference in the serum BDNF level among the traumatized subject as compared to control. As you can see, there is a decline in traumatized subject for BDNF, while for CRP, no significant difference was found in CRP level. Only a slight increase was seen in the traumatized subject. The cognition level that we determine using the 6-CIT score indicate that cognitive decline was more pronounced among the traumatized subject as compared to the control group with a significant positive difference. Hence, concluding that traumatic stress can be associated with cognitive decline, BDNF, cortisol, whereas a non-significant association was also found within interleukin 6 and CRP level. On basis of our result, we can say that these alteration in the biomarker can lead to diseases in future, neurological diseases, including Alzheimer, Parkinson, dementia, post-traumatic stress disorder, and other neurodegenerative diseases. Thank you. Okay, now moving on to our next poster.
Okay, our next presenter is Ms. Kamal Iftikhar from HEG Research Institute of Chemistry, and she will be presenting on modulatory effect of quinic acid on the proliferation and differentiation of hippocampal cell. Kamal, are you there?
Yes, ma'am, I'm here. Am I audible? Hello?
Okay.
Hello, I am audible? Am I audible?
Kamal, you are audible, yes.
Okay, hello everyone. My name is Kaval Iftikhar and I am affiliated with International Center for Chemical and Biological Sciences, University of Karachi as PhD student under the supervision of Dr. Shabana Usman. Today I am presenting our study that is regulatory of quinine on the proliferation and differentiation of hippocampus. Our objective is to help in the generation of neurons to recover logic acid in neurodegenerative disorders. For that purpose, we have isolated sample cells from rats and cultured them. After that, we perform MTT assay to investigate the effect of quinic acid on neurogenesis. We observed that quinic acid has demonstrated a remarkable growth supporting effect on the hippocampal neonatal cells. So basically, this study is designed to evaluate the mechanism of quinic acid by which it accelerates the process of neurogenesis. As you can see that dose of 100 micromolar Quinic acid significantly increases the rate of proliferation at 24 and 48 hours, but at 72 hours, proliferation slightly decreases due to the of gas. Following the treatment of Quinic acid, hippocampus cell was visualized by contrast microscopy under 10x and 10x application to evaluate its effect on cellular morphology, differentiation, and propagation. At 24 hours, no dramatic morphological changes were observed, while there is significant morphological information can be seen at 48 and 72 hours. You can see that mature and differentiated neuronal cells replace large population of fibroblast cells. Expression analysis also confirmed the Quinic acid's potential to generate neurons. Our compound increase the gene expression of neuronal markers, tubulin, neuroD1, neuroligin, and neuroexpression. Gene expression of nestin, that is the neural stem marker, also increased by Quinic acid, whereas the blast marker after the treatment of Quinic acid, and no change can be seen in case of GFAP that labeled sites. Our study proved that Quinic has a potential to accelerate neuronal cell in HP cultures. Our future are immunochemistry and Purdue assay. I thank my supervisor, Dr. Usman Simji, for her support and other co-authors. Thank you for your time.
Thank you, Kawal. Now we are moving to our last poster. I will share the screen. Okay. Our last poster presenter is Ansab Akhtar. Ansab, are you there?
Hello, good afternoon, everyone.
Good afternoon. Ansab, your time start now.
So I'll be presenting about the 7,8-dihydroxyflavone, which attenuates cognitive deficit in a model of intracerebral ventricular streptozotocin, which is a model of sporadic Alzheimer's disease. So this drug, 7,8-dihydroxyflavone, acts by reversing oxidative stress, mitochondrial dysfunction, and insulin resistance. This is a flavonoid, which is a well-known PRK agonist and which has been already used in a transgenic mouse model of Alzheimer's disease. But in this case, I have used a model of sporadic Alzheimer's disease, which is more prevalent, which is almost 95% prevalent in all of Alzheimer's. So the study in this study on day 0 and day 3, I have injected streptozotocin through the intracerebral ventricular route on a spirotaxic apparatus in a dose of 3 mg per kg. On day 14, I conducted active photometer for evaluating locomotor activity, and for recognition memory, I conducted novel object recognition test, and spatial memory was evaluated by Morris Waterman's test. On day 26, animals were sacrificed, removing the cortex and cerebral cortex and hippocampus, and also the entire brain was also removed for histopathological analysis by hematoxylin and eosin. It was further on the region of cortex and hippocampus, various oxidative stress parameters like reduced glutathione catalase, superoxide dismutase, glutathione peroxidase were conducted. In addition to that, mitochondrial dysfunction was evaluated by the activities of different mitochondrial complexes. And insulin resistance was evaluated by the ELISA of insulin degrading enzyme, which is an insulin resistance marker. And the tau pathology was found out by the ELISA of phosphorylated tau. In the results, it was found that there were no significant changes among the various groups. Various groups of like control rivastigmine group, which is the standard drug rivastigmine in this case, and 3 doses of the drug. So this shows there was no effect on locomotor activity. But in case of a novel object recognition test, it was found that the 7,8-dihydroxyflavone as well as showed increased discrimination index. That means the animals were able to discriminate two different objects. Very well. In Maurice Watermaid's results was found that escape latency was found to be decreased in case on day 3 and 4 in case of the test drug as well as the standard drug. This shows it is improving the spatial memory. In case of body weight, it was found and day 14 and day 21 body weight was slightly improved by the treatment of the drug. Various antioxidant enzymes like catalase, superoxide dismutase, glutathione peroxidase was also found to be increased by the treatment of 7-dihydroxyflavone, which indicates that it has reversed the oxidative stress produced by intracerebral ventricular streptozotocin. Nitrosative stress was also found to be reversed in case of treatment with 7-DHF as well as rivastigmine. In addition to that, phospholate tau protein was found to be significantly increased in case of a disease group, that is the ICS group. This shows that model of Alzheimer's disease has been established. In addition to that, insulin degrading enzyme, which is an insulin resistance marker and which is responsible for degrading amyloid beta as well as insulin. So its level is decreased in case of the disease group, but the treatment with 7-DHF shows its level increasement. This shows that this drug has improved the means reverse the insulin resistance by increasing its level. In the histopathological analysis, it was found in both the region of cortex and hippocampus. There is more neurodegeneration, which was inferred by the dark neuronal hypnotic cells and disfigured nucleus in the ICV-STZ group, and there were a slight improvement with the lowest dose of the 7-DHF, and further the doses of 10 mg per kg and 20 mg per kg of dose, it improved. It must have improved the neuroprotection, because in these cases of in the region of cortex, there were more number of neuronal cells, which shows a better survival, which was inferred by the decreased number of neurodegenerative hypnotic cells. And in this case, the standard drug has also improved almost incomparable to the highest dose of the 7-DHF. Similar kind of results were observed in hippocampus, where excessive neurodegeneration was found in the ICV-STZ group, and subsequently, the doses of 10 mg per kg and 20 mg per kg of 7-DHF has improved the neuroprotection, which is clearly observable in these slides. And the dose of rivastigmine in the 2 mg per kg has also proved us almost similar kind of results as compared to highest dose of 7-DHF. So these results can be concluded that this flavone, 7-dihydroxyflavone, has the potential to reverse oxidative stress by reversing different antioxidant enzymes, and it has must reverse reactive oxygen species. In addition, mitochondrial function has been improved. Further, these histopathological analysis gave that this has produced neuroprotection, which can be confirmed by the behavioral results, improving the spatial memory as well as recognition memory. So this was briefly about this poster. Thank you.
Thank you, Ansaf. Ujala, you can unshare the screen. I would like to ask Dr. Bilal to please take on and just continue with the comments and overall evaluation of the poster.
Thank you, Dr. Sadaf. Am I audible to everyone?
Yes. Dr. Bilal, can I make one more announcement, please? If anyone have the question for the participants, you can write it in the chat. So after Dr. Bilal will complete commenting on the posters, we can have some question answers from the presenters.
All right.
Over to you, Dr. Bilal.
Thank you, Dr. Sadaf. Thank you very much. Regarding the presentation done by Rida Nisar, I want to ask Rida Nisar, are you there, Rida Nisar?
Yes, I'm here.
All right, Rida, how many days, my query is just one query, that how many days, number of days you conducted that experiment. Did you explain it in your presentation?
No, I didn't explain it in my presentation. I conducted this entire experiment in a whole day that includes behavioral analysis and induction of anxiety. The samples collected were then later analyzed.
Or later analyzed. All right, okay. And you
They
use
were
the
stored at minus 50 degrees centigrade.
and you use the albino rats for that.
G albino rats, Vistar albino rats, male, and they weighed from 230 gram to 250 gram.
All right, okay, great. Thank you, Rida. Maha Shahid, she conducted a study on TGF beta signaling pathway.
Yes, I'm here.
Yes, Maha. What does this test compound, isoxylitone, do actually? I mean, for what purpose it is used officially? You conducted that for.
Okay. This compound is being synthesized here in ICCBS by Dr. Ataur Rahman and his research team, and its mechanistic studies have already been done and it's published. I have provided the reference here. It acts by inhibiting the sodium ion channels. It acts on sodium ion channels, and it's primarily it's an anti-epileptic compound.
All right, okay. Thank you, Rida. Maha.
You're welcome.
Now, Asia Afzal, she worked on curcumin in reversing the depressions. Asia, are you there?
Yes, sir, I'm here.
Asia, I think that literature is full of evidence on the use of, curcumin and its effect on pseudodementia. Um, um, what public health, implications are there in terms of your study, what you have conducted? I mean, what is the main purpose? We can see that curcumin has an effect on the pseudodementia, but since the literature is available, I think I've looked around.
Yes, sir. A lot of literature or curcumin has been available on memory and as an antidepressant, but I focus on pseudodementia, and there are studies of curcumin in which they focus on pseudodementia. And the uniqueness of my study is that I use to evaluate pattern separation test, and the other thing is that I have done some receptor studies and some other biochemical markers which are not included in this presentation. So if they will be included, then you can see the uniqueness of my study. But due to time limitation, I have not included that markers and receptor studies.
Markers as well, it would become a great study because probably the work on markers have not been done, probably.
Yes, sir. I have studied receptors and there were some markers also. I have not published yet, and due to time management, I have not included all the parameters because it was my PhD work, so it was not possible to give all the
But I
parameters
would
here.
suggest that if you focus on receptors and markers as well, it would come up and you can get more citations of your work, hopefully in the future. All right, Deepak, the role of antidepressant effect of morin hydrate in mice with stress. Deepak, are you there? I just want to make a comment for Deepak's presentation that he did presented very well, and he explained all the parameters of the study and uh, the methodology. It is a good study, and I wish you all the best for your future work with that particular domain. Asia Afzal have done Sumbul Zehra. Sumbul Zehra, you explained very well the role of cardinolites in glioblastoma, and it is a very well, well explained and well focused study. And I wish you all the best. It's a good study.
Thank
So
you.
congratulations on that. Mariam Ejaz, microemulsion based synthesis of strontium hexaferrate cobalt iron particles. Mariam, what are the policy, unique points of that study that you can sell on in the literature that you have done a great work? Obviously, it's a good work and you explained it very well. But I just want to know that what are the policy implications? How would you, you know, propagate these results and what are the major implications? Mariam, are you there? Mariam Ejaz. All right. Um, um, Hira Rafi. Hira, are you there? Hira Rafi. Inhibition of NMDA receptors by augmentin. Hira.
Hira? Sir, Hira is present online, but she isn't opening her mic.
All right. I think she is not there. She has not responded.
Yes.
Okay, she's got some mic connections. Okay. Anyway, but I just want to ask Hira that Hira did not mention the you know animals on which the experiment has been done. She just said that test has been done on animals, but she has not told us. Probably these would be the mice.
Maybe, sir,
That's
I will send your query to her.
okay. Thank you. Thank you. Thank you. Meena Gupta,
Yes,
cognitive
sir.
enhancement in neurodevelopment delayed children using transcranial magnetic stimulation. A very well planned and very well explained study, and I congratulate on your work. It's a very well explained and well planned study. So thank you very much for your effort and all the best for your future, work. I wish
Okay,
you all the
thank you,
best.
sir. Thank you,
Thank
sir.
you, Meena. Thank you. Yusra Salim, the age-related cognitive decline. Uh, uh, Yusra, we already know that with the decline of the age, we have got a cognitive, delineation as well. So, what is the public health implication like overall unique availability of the points?
Sir, actually, we meant to assess the age-related cognitive impairment through MMSC and MiniCog, and this pilot study aimed to analyze the two of the scale on our population, so that we can assess the age-related decline with these two tools and also validate whether it is possible or not, or the results will be applicable on our set of population, and so that we can then have a full descriptive longitudinal study.
That is the point. So I suggest that your presentation was well explained and well written, and we can see the presentation for whole all the text easily. But I just want to make one comment to most of the presenters that kindly do look after the the presentation as a whole as well, that people can easily read what you are talking about, and they can read the text as well. Some of the presenters, for example, the last presenter, Ansab Akbar, who did something on, I couldn't understand the whole study. I just listened to that, but actually the presentation was very, well, all the text is very minutely written, and I couldn't see the diagram as well, and how the diagram was presented. So it is, it took me difficult to understand. But anyway, he presented well. Kamal Iftikhar, it's a good study, modulatory effect of quinic acid on the proliferative and differentiation of hippocampal cells. I
Thank you,
looked
sir.
after the literature as well, and I think that there is no, just for a short span of time I saw, and I found that there is no effect, there is no study and no literature been available on the role of quinic acid on the proliferative differentiation of hippocampal cell. Am
Yes,
I
sir.
correct? Novel?
Yes, yes, you're correct, sir.
All right.
This is a novel study.
Okay. So I would suggest that you should go for a publication and
Yes, sir.
without delay of time.
So actually, this is incomplete work. I have to do some more experiment, as I have mentioned in my presentation that I want to done immunocytochemistry. Then I will definitely publish my work.
Thank you, Kamal. Now come to Mr. Faizan Mirza. Faizan sir, you did conduct on non-invasive indication. Sorry? Hello?
Sir, I am
Ujala, you were saying
Ijaz.
something?
Sir, I am Mariam Ijaz. Kindly repeat your question. There was a network issue.
Okay, Mariam. Mariam, what are the policy implication of your topic that microemulsion based synthesis of strontium hexaferrite cobalt are particles? How, I mean, would you say that it would be helpful for the population, your study?
Yes, sir, it is very helpful because nanoparticles are in our environment, like in smoke, in petroleum, and many other things. Nanoparticles are used like cobalt, iron, and strontium hexaferrite. Actually, these nanoparticles were made by the material science students to check about their implication on the human beings. So we will work on it on the albino mice.
Okay, all right. Okay, so kindly, it would be great if you incorporate that particular point that this is the unique idea and this is the unique selling point of my study. So it would, help
Yes.
to understand the people in layman term probably because research, if not well understood by a layman person, it would be a slightly waste of time.
Yes, sir, sure.
All right. Okay. Mr. Faizan
Thank you,
Mirza,
sir.
thank you. Non-invasive indicators of neurological decline. Mr. Faizan, well done study, well explained, and PowerPoint was well defined and well written and well, presented. I congratulate you on the work. But one query of mine is that with different age group, you said that age between 20 to 26. We have. Did you mention that you used any inclusion and exclusion criteria for the study participants? Hello. I think
I think
Ujala.
Dr. Bilal, we should move to the last presenter or some comments and conclude this. I think Faizan is not there, or there might be some connection issues.
All right. I just wanted. Yes, probably I can understand. Thank you, Dr. Sadaf. All the presentations were well explained, and there were some points I would want to mention that please do, make your presentation in terms that people can easily visualize it properly, and the text should be, easily readable so that, and the diagram as well. Less busy the presentation should be, presentation slide, and that would be helpful. And please include the public health implication so that that can be understood and well taken up. So that were my points, Dr. Sadaf, and over to you.
Thank you so much. Thank you so much. Faizan, you are here. Actually, Dr. Athar is also here to conclude the session. But we have a question for you. So if you can answer Dr. Bilal about the exclusion and inclusion criteria.
Sure, miss.
Assalamu alaikum, Faizan sir.
Dr. Bilal, can you repeat the question, please?
Yes, my question is that you explained the study very well, and you mentioned a very important point that with age, weakness in the hand grip strength, the mortality can be can be seen that mortality can be predicted. My question, only one question, is that did you use any inclusion and exclusion criteria for your study participant? in terms of hand grip?
Dr. Bilal, can you repeat the last part of the question? There's internet is lagging. I missed the last part of the question.
All right. Okay. I just wanted to ask that did you use any inclusion and exclusion criteria on the based on hand grip strength?
There was the inclusion and exclusion criteria that we followed for the study. Basically, it was just that we took individuals who did not have any kind of diagnosed illnesses, any kind of diagnosed disorder, be it a motor disorder or be it any kind of allergy to any kind of fragrances or any smells. So we excluded the individuals who had asthma or who had allergies because olfactory performance had to be assessed. Another thing, motor skill disorder individuals were also excluded. I use the term in my poster that we included apparently healthy individuals. So all the 412 participants of our study, they were all apparently healthy. They did not have any diagnosed illness. So that covered almost all the features. So even if a subject was falling into our criteria, then if that individual had a diagnosed illness, we excluded that person.
You answered well. And what about the age group? Because young children have comparatively weaker hand grip strength as compared to the adolescent and the adults. So did you include any particular age group in your study? I think it was 20 to 26.
The age group that we included in our study, we did not include any individual below age 20. So we started our the youngest age group was from 20 to 36. This age group was the youngest, and beyond that we had the individuals from age 37 to 55, and then from 56 to 70. These were our three age brackets that we use. So we did not have any minors or anyone below age 20 being tested for either hand grip strength because of various hormonal changes that actually are going on in ages before 20.
Right, Faizan sir. Thank you very much. Well explained. And I wish you all the best because it is one of the best study presented today. Thank you, Faizan sir.
Thank you so much. Thank you so much, Dr. Bilal. That means a lot for such praiseworthy comments. Thank you so much.
Thank you.
Thank you, Dr. Bilal. And this is time to just close the session. And we had the whole week of the talks and the lab tutorials. And I hope that you all have some feedback, and we are collecting the daily feedback. But before closing the session and sending you some important information, I have to welcome Professor Dr. Athar Enam again in the session. Sir, you were there to start the session, and now we are closing the session. It is up. We are looking forward for your comments, and also how we can take this forward and how this school can be beneficial for Pakistan neuroscience group on whole.
Well, thank you, Dr. Sadaf and Dr. Bilal, and all those I know, Dr. Faizan and all the worthy participants. This was a wonderful event. Actually, I did sneak in middle now and then, and Dr. Tran is also here. So I would sneak in now and then to see how things are going through the week. A wonderfully done event, and connects to what you have been doing from over the last decade through ARC, through different organizations, and whatever you have done through the IBRO associated schools. So this is definitely a step up, and if you compare the quality of the previous schools, one can feel that things are getting better, improving over time. And I think we need to just continue on this. I was so impressed with some of the presentations that Dr. Bilal was commenting on. This is the kind of thing that we need to have for our PASBAN, and we need to have more neuroscientists come together. So I will sneak in the message about the PASBAN also in this, and Dr. Sadaf is General Secretary of PASBAN. So please, let's come together as the neuroscience community of Pakistan. I think whether it's a degenerative diseases, whether it's a study of cell channel, or whether it's a psychological study, it's all neuroscience. And we have a very good, strong, robust community of neuroscientists in Pakistan. It's just that we are not together to show the strength. And I think once we start to come together on one platform, uh, we will be able to do wonders, because that's where the networking will start. So all these things that Dr. Sadaf, that you have done with all the people that have supported you from IBRO, from AEIRC, from University of Karachi, Yusra, I remember, I don't see Yusra in here. She has always been very helpful. No, Yusra is there, right? So all those people who have helped you, I think this is definitely a big step moving towards coming together as the neuroscience community of Pakistan.
Thank you so much, sir. It was a wonderful experience indeed. And there were some very good presenters related to their research work, but there were also very good presenters from different communities that we joined, especially today's morning was actually covered by Dr. Deming from Malaysia, and IBRO recommended him. He was the lecturer of university there in Young Scientist Academy, and he delivered a very interesting talk on the neuroethics and how we can pursue for the neuroscience research and how we can follow the animal and human ethics. So it was a very wonderful thing. And then we had the clinical talks from Dr. Jean King, and she was there. And then her associate, Dr. Ban, was also there. So beside the time duration and beside the time duration changes, we always had these presenters, and Dr. Jerry DeBoer, Professor Dr. Jerry DeBoer was there to just explain the presentation and the video track to all the participants. He was there to present and do the question answer session. So it was again a good show. I think, sir, we actually missed you in the lab tutorial session where we have conducted and tried to conduct labs online this time. And we actually had the whole stem cell lab and the calculations and lab things all in the video, and with the help of board and marker, Ruxana Nawaz taught all the solutions and how the media can be changed and everything from Alan University, UAE. So she used to be one of our students in IBRO, first IBRO in Pakistan, and now she is the teaching faculty at Alan. So actually she made the 2-hour video, and she was there to teach, and she was there to interact with. And then Faizan also did a very great job in teaching a student and doing the activities. So I hope they have learned a lot from the tutorial that we tried to conduct online. But hope so next time we will be able to invite them via PASBAN and this collaborative effort to Pakistan physically.
Inshallah, inshallah.
Because it was planned, and I hope that we can do so in future. Everyone is requested to just turn on the camera so we can take one picture to close the session, and we will be looking forward for Ujala will be taking the pictures. And let me just announce some. We have a whole abstract book that will be uploaded in a while on the website that I have provided to you. All the 6-day session will be provided to you, and it will be uploaded on the website as well. I am very much thankful for all the participants who are patiently waiting for this school to get started when they were selected physically, and they were supposed to visit us in Pakistan. So all the international participants from Nepal, from India, from Malaysia, from Myanmar, everyone is so much appreciated that you guys keep on believing us, and still you are here to join us online after these whole 1.5 years. So thank you so much for your dedication, for your learning, collaboration. I can see Dr. Deepak as well. Dr. Deepak was also very much keen in every lecture, and he was asking the question. Thank you so much. everyone from outside the Pakistan and from different cities of Pakistan. Thank you. I think we are about to take the picture. Okay. Thank you so much. We will be looking forward.
And if we can unmute ourselves, we can also clap, right? So we can, people will hear that. No, you gotta. Everybody has to unmute them now. Some of them unmute kar le, and then clap so we can all hear it. Unmute everybody. Unmute. Okay. So 1, 2, 3. ऐसे भी हो जाता है. That's good. Wonderful job, Kasadaf. Very proud of you.
Thank
Very
you.
proud of
Thank
you.
you. All the students and all the presenters will be getting the certificate, and we will be emailing you shortly after the session completion. Don't forget to mark your attendance for today and the feedback for today. And we will be looking forward to you, as Dr. Athar said, to connect. And
everybody has to unmute them now.
Soon we will have our presenters. We will have our conference in October of neuroscience in Pakistan.
1, 2, 3.
All of you. Thank you. Thank you so much.